Hello everyone. Let's see the compiler design GATE syllabus. Right? This is the syllabus. First chapter is introduction to compiler design. Second one is lexical analyzer. Third one is parsers. Fourth one is syntax directed translation. Fifth one is intermediate code generation. Sixth one is code optimization. Right? This is the new one added. Right? This is the new one added. Right? So until last year GATE examination, only 5 chapters are there, 1 to 5. Right? This year newly added code optimization. Anyhow, these are the 6 chapters. And one more thing I want to say to you, listen, it is going to be very easy topic. Total compiler design is going to be very easy, right? One time you listen. If you don't listen my lectures, I am saying to you, right? There is 1,000 pages. 1,000 pages, one book is there. You have to refer that book. 1,000 pages reading, now it may not be possible at all. Best idea. All my lectures you listen, right? It is a very small topic. It don't take like algorithm and data structure because they are the core subject, algorithm and data structure. So to cover them, it is taken some time. But one thing, this is going to be very small topic, right? Listen properly. Whatever I will say, try to get everything. That is enough. So this is the syllabus, right? And one more, some people are asking, sir, which are important topics? One thing I want to say to you, as a computer science student, it is your minimum responsibility, right? What the compiler contain, right? What the compiler contain, what the everything will do. It is your minimum responsibility. Marks purpose don't read this one, right? To understand how the compiler is working. For that purpose you study, right? So as a computer science student, it is your minimum responsibility how compiler is working. What is there inside a compilation, what is there, right? Everything you have to learn. At the end, one more thing I want to say to you. GATE exam purpose you are preparing, right? You have to take care about GATE only. That is fine. Marks purpose don't study. I want to say meaningfully you study one time. Plus, right, after completion of my lectures and all, right, workbook also you see. To this subject especially I am saying to you, my lectures followed by workbook enough. My lectures followed by made easy workbook, it is more than enough. Right? Afterwards, if you have time, previous papers also you can see. Right? My notes first, followed by, right, made easy workbook. That is more than enough. Through experience I am saying to you. Right? Let's start. Some students are asking what are the important topics, right? What I want to say directly is important topics I will say, right? But no one knows what is going to come, right? No one knows. So best thing is, right? Try to get everything once. I want to say important topics. If you study only important topics, what is the problem? Suppose that you are studying only important topics. What is the problem? If you are unlucky, other than important topics may come, then you will feel bad. Best idea, all the things one time you will listen because it is very small topic. It is very small, right? It will take maximum 5 days, 6 days, something like that, right? Try to listen all my lectures first, followed by workbook. That is more than enough. Let's see the first chapter of compiler design, that is introduction to compiler design. I'm again repeating to you, I'm again saying to you, to get the compiler design subject, right, the best possible way is, right, listen my lectures properly. Otherwise 1,000 pages book you have to read, which may be difficult, right? So concentrate at least from now onwards. Whatever I said until now, some syllabus and all I said to you, right? From now onwards, careful. Introduction to compiler design, right? What it is, I will explain. Right? On your program, you done the compile. What are the first step going to be happened is, this is the first step. Right? Preprocessor, right, will execute. On your program, if you say compile, the first thing which is going to be happened is preprocessor will come into the picture. Preprocessor. Right? On my program, I have one program, I said compile on that program. First what happened is preprocessor will come into the picture. Preprocessor. Some people are asking, to this preprocessor, what are the input? Normally you think that when you say compile, right, on your program will be compiled. You may think like that. No. First preprocessor will execute. On your program, compiler will not execute first. Preprocessor will execute. Right? Some people are asking, sir, to this one, what is the input? To this one, input is going to be your program. Normally, our program is going to be a high-level language program. See, high-level language. So, for the preprocessor input is going to be high-level language program. Please be careful. High level language program is the input to the preprocessor. So I have a C program. Normally I will talk about the C program only because in the GATE syllabus C programming is there. In GATE syllabus, if at all Java programming there, I could have spoken about Java language. Normally I will talk about the C programming only because in the GATE syllabus C programming is there. That is the major reason. Can you help me now? I have a C program. I said compile. Normally you think that compiler will start. No. First pre-processing will start. First preprocessor will come into the picture. To this preprocessor input, high level language. Normally our C program, whatever C program you write, whatever Java program you write, whatever C++ program you write, normally those are called high level language programs. So preprocessor input is going to be high level language program, right? Please be careful. This is the introduction of the compiler design. Please try to get here only. So to this preprocessor input is going to be high level language. Some people are saying high level language input to the preprocessor, it's okay. What the preprocessor output? Preprocessor output is going to be, listen, preprocessor output is going to be, this is the output. See this one, pure high level language. Pure high level language. Input is going to be high level language, output is going to be pure high level language. Some people are asking, what is the meaning of pure high level language? What is the meaning? Nothing there. In your program, somewhere some shortcuts you written. Somewhere you written some shortcuts. Those will be replaced by by preprocessor. Right? While writing the C program, somewhere you used some shortcuts. Right? What the preprocessor will do is, it will replace all shortcuts by actual thing. User, for his convenience, he written the some shortcut. Right? Preprocessor will replace shortcut by actual. Right? Please be careful. That is the purpose of the preprocessor. Some students are asking me, preprocessor purpose is, it will replace all user defined shortcuts by actual. Some students are asking, sir, can you give one example for that, how it is happening? Something like printf. Some people are, what is the meaning of this? In your program, in your C programming, right, you are using printf function. You don't write printf code. You are using printf function, but you don't write printf code. But instead of writing, you will say one line. What is that one? Hash include stdio.h. What is the meaning? Right? In the standard header file, input-output functions are there. Input-output functions code is available. Please include that code inside my program. That is the meaning. So you are using the printf function, you have to actually write the code for that. Instead of writing the code for that, you are using one shortcut. What is that one? It is there in the standard header file, right? Please include that code in my program. That's what you are saying, right? Some people are asking, hash include stdio.h you said. And after saying that line, you are using printf. Now what the preprocessor will do is, he got to know, okay, right, user is saying that he is using the printf function, but code is there in the header file, right? I have to include that code, right? That code which is there in the header file, right? That code in his program. Preprocessor got to know, he will do that. Final line, preprocessor purpose, it will replace all user defined shortcuts by actual. Please be careful. Can I help you now? Preprocessor input, high level language, output, pure high level language. What is the meaning? In the high level language, some shortcuts may be there. In pure high level language, those shortcuts also not there. One shortcut also not there. He removed everything. All shortcuts he removed. Right? Please be careful. Right? I'm thinking you are okay. Some people are asking, sir, can you give one example? What the preprocessor will do? Let me do that also. See this one? One small example I want to say that. Make sure that you listen this also. See, listen everyone. Main. What this example will do? Let's check here. See this one? See everyone now. When you compile this program, what preprocessor will do? I will explain. See this one? Compile this program. When you compile, what happened is, careful listen. When you compile, what the preprocessor will do is, see this one. You are scanning, see this one. When you compile this program, what a preprocessor will do is, see this one. What is the meaning of this one? Has defined square of x into x. What is the meaning? Right? You are defining square of x is nothing but x into x. You are defining square of x means x into x. That is the thing what you are defining. What can you help me now? In this statement, which is the shortcut, which is the actual? Actual thing is x into x. To that, they are given the one new definition, square of x. Actual thing is x into x. To that one, they kept one rename. means rename is nothing but shortcut. It is the actual, it is the shortcut. So we are defining this is the actual to the shortcut is this one. That is the thing what he defined. User is written like this one. What the user written? This is the actual thing which may be big also. Sometimes it is a very big. This is the actual thing which may be very big also. For that they will give one rename. Yes, they are given the rename, everything is fine. In this program he may use that rename many places, because of this is the actual which may be big many times. There is a big code, right? Instead of writing this big code many places, what is the best idea? To this give the rename which is a small name. You can use that rename many places. Now what the preprocessor will do is, he will, whenever you compile on this one, first preprocessor will come to the picture, he will come inside, he will go, where is the rename, means where is the shortcut. Can I suppose the actual here? This one. What is the shortcut? This one. So what the preprocessor will do is, he will come inside, where is the shortcut he will see, I think the shortcut is this one, square of x, he will replace by actual. What is the actual? X into x. In this program, assume that shortcut is there in many places. What the preprocessor will do is, he will replace shortcut by actual. He will do that. After everywhere, he will replace shortcut by actual. After everything is done, preprocessor will remove this line. That is the thing what the preprocessor will do. Preprocessor, one more functionality is going to be replacing shortcuts by actual, it's okay. One more thing is going to be, he will simply replace. You don't do any processing. You don't do any calculation. Preprocessor don't do any calculation. Before going to the processor, he will do pre-processing. Pre-processing only will do. Means what the preprocessor will do? He will substitute. He will replace, substituting is nothing but he will replace shortcut by actual. That's it. You don't do any calculation. Preprocessor don't do any calculation. It will do only substitution. Right? Please be careful. If you want, I will write the note also. See the note. See the note now. Preprocessor don't do any calculation. Preprocessor don't do any calculation, but it will do only substitution. Right? Please be careful. Preprocessor don't do any calculation, but it will do only substitution. It will do only substitution. It don't do any calculation. Substitution. Some people are asking, what is the substitution? Actual. Listen everyone. Shortcut replaced by actual. That's it. And one more. What is the answer? One more functionality I said also. Printf function, right? I will use, but I don't write the code. I will say where is that code is there. Right? Preprocessor will go there. He will bring that code. He will add inside our program. Right? That is the one more functionality of the preprocessor. We indirectly, directly replacing shortcut by actual. That's what the preprocessor will do. Preprocessor don't do any calculation, but it will do only substitution. Some people are asking, sir, what is the output of this program? Let's see the output. Right? So can you help? Preprocessor don't do any calculation, it will do only substitution. See this one. First he will see the okay. What is the actual? This one. What is the shortcut? This one. Right? He will go inside. Wherever shortcut there, he will replace by actual. After replacing is over. After replacing is completed, then he will remove this line. After removing that line is over. Now if you want, you can execute. I think pre-processing is over. Now you can do some calculation. What is the answer? This line is equal to, I think into y, x is equal to 4. Then y becomes, what is the answer? Y is equal to what? 64 by, right? What is the answer? X value 4 into 4. You don't do any calculation, right? So y is equal to 64 by x into x, means 4 into 4. You know very well. What is the answer? Multiplication and division, which is having highest priority, both same. Then what is the associativity? Left to right, it will be done first. 64 by 4, what is the answer? I think 16 into 4, 64. So y becomes 64. Printf y, 64 will be printed. Is not done any calculation. Some people think that, right, 64 by x value 4 into 4 becomes 16, right? 64 by 16, 4 will come. No, because preprocessor not doing any calculation, only substitution. After substitution, it will become like this. Now normal, whenever it will go to the processor will see, right, which is the highest priority. Both are same priority. What is the associativity? Left to right. So 64 by 4, 16. 16 into 4, 64. Y becomes 64. So 64 will be printed. Many people know, only for namesake I explain. Can you help me one small line now? Right, when you say compile, what is the first step going to be happen? Pre-processing. Means pre-processor will come into the picture. Means on your program, first pre-processing is going on. Now can you say for the pre-processor input high-level language, output pure high-level language. What does that mean? No shortcut there. No shortcut there. All actual things are there. Now this will be the input to. This will be the input to. Who is the next person? This will be the input to the everyone know. Right? This is the input to the compiler. When you say compile, immediately compiler don't start. First pre-processing, then I think all the shortcuts are over, then compiler will come to the picture. Compiler, can you help me now? For compiler input, pure high level language. Compiler input is going to be pure high level language. Output is going to be, careful listen, output is going to be, right, low level language. Output is going to be low level language. Let me write now. Output is low level language. Input is going to be high level language, pure high level language. Output is going to be low level language. Some people are asking, sir, can you give one example for high level and low level? Let me give one example. See this one. In high level language, if you want to add two numbers, you may write a plus b in high level language. But in the low level language, if you want to add a and b, right, this may be like this one. Add, right, r1, r2, something like that. This is the one. It is a high level language. See, user convenient language is high level language. Machine convenient language is low level language. Some people are asking, sir, can you give one more example? This may be like this one. See, multiplying two number, a into b. But in the low level, what is the answer? Mul. Right? R1, R2. Right? Something like this. This is the high level, this is the low level. Please be careful. Now see this one, compiler input, pure high level language, output, low level language, which is also called as, what is another name? Machine language. Machine language, right, which is also called as, right, see this one, which is also called as low level language, machine language. Another name is going to be assembly language. Assembly language, right? When I say compile, first preprocessor, it will give output as pure high level language. That is the input to the compiler. Compiler output is going to be low level language, which is also called a machine language, which is also called a assembly language. Everyone know that. I given examples also. What is the answer? A plus B is the high level language. Add R1, R2 is going to be low level language. What is the meaning of low level language? Only machine can understand that. Only machine can understand. Machine means what? Processor. Processor can understand only low level language. If you say A plus B, user can understand. If you say add R1, R2, processor can understand. That is the reason it is also called machine language or low level language. Low level language only processor can understand. A star B, user can understand. That is the meaning of high level language. Mul R1, R2, right? Processor can understand. That is called machine language, which is also called assembly language, which is also called low level language, right? Fine. Everyone fine. Now listen now. Now listen. This is the input to. Carefully listen. This is the input to, right? Assembler. This is the input to assembler. Now people got to know why it is called assembly language. People got to know why it is called assembly language, right? You are giving that language input to the assembler. That is the reason it is called assembly language, right? This is the language of the processor. So machine language, processor can understand only low level language, right? I think low level language. Processor can understand only low level language. So output of compiler is going to be low level language, machine language. And one more, this is input to the next person, assembler. That is the reason it is called assembly language also. So assembler, right? Assembler is the next one. Can you say assembler input, assembly language? Assembler input is going to be assembly language. Some people are asking me, what is the output of assembler? Assembler input is going to be assembly language. What is the output, right? What is that? Let me write now. Output of the assembler is going to be, right? Let me write here. Output. See this one, output. Relocatable, machine language. Relocatable, low level language or machine language or assembly language. Right? Please be careful. Assembler output is, input is going to be assembly language, output is going to be relocatable low level language or relocatable machine language or, right? So next one is relocatable assembly language, relocatable right, low level language or machine language or, right, assembly language. Please be careful. Relocatable. Some people are asking what is the meaning of relocatable? What is the meaning of relocatable? Suppose assume that before assembler, assume that before assembler your code is there in the hard disk. Assume before assembler your code is there in the hard disk. You want to move to main memory, right? It may not be possible because assembler will convert relocatable code. What is the meaning of relocatable? You can relocate that code from one memory to another memory. Right, if at all assembler is not there, you cannot move the code from, right, one memory to another memory. It will give the permission to move from one memory to another memory. Some people are asking, sir, without assembler I will move the code from one memory to another memory. What is the answer? There may be chance that data loss may happen. Right, so listen, after compilation is over, you got the assembly language, machine language or low level language, it's okay. But one thing, you cannot move this code wherever you want. You cannot move. You got the machine language, it's okay, right? You cannot, you know very well. Some people are asking me, first of all, why should I move? Initially code is there in the hard disk. Whenever code is running by the processor, code should be there in the main memory. Initially code is there in the hard disk. When that code running by the processor, code compulsory should come to main memory. Means you have to move that code from hard disk to main memory or hard disk to cache memory. You have to move. Suppose if you want to move, assembler first should be done. If at all it's not done, you cannot relocate the code from one memory to another memory. If you do that, there may be a damage to the data. Can you help me now? So assembler input, assembly language, output, relocatable assembly language, or relocatable low level language, or relocatable machine language. Please be careful. Without assembler, if you move code from one place to another place, there may be a damage to the code. Please be careful. It will give the possibility of moving the code. Relocation possible because of assembler. Because of assembler, relocation possible. Means one memory to another memory, it is possible. If without assembler, if you do that, right, some problems may come. It is something like this one. This assembler is nothing but something like this one, right? There is, you know very well, when you are Indian, right, you want to go to US. You are Indian, you want to go to US. Everything is ready. But if you want to go from India to US, compulsory you need visa. If visa is not there, right, suppose isn't that you are Indian, you want to go to US. If you go directly, that is also may be possible. If you go directly, some damage will happen. What is that one? You are Indian, you want to go to US, without visa you went, right? Then what is the damage going to be happen? Because of you went to US without visa and all, right? Definitely you may not come back. Mostly you may not come back. If you come back also, maybe your leg may not be there. Your hands may not be there. Your fingers may not be there. Right? If my guess is correct, your head may not be there. So what I want to say indirectly, you are Indian, you want to go to US, compulsory visa required. Without visa also possible. If you go, you may not come back. If you come also, one of your body part is gone. What is the reason? You didn't follow the procedure. When you take in the visa, what is the meaning? You have the ability of now going from India to US. You have the chance. Please be careful. Same thing like assembler. Without assembler, if you move the code from one memory to another memory, some damage may happen. Same thing, without visa, you are going from one country to another country, some problems will happen. Same thing like this, right? That's what the assembler will do. Can you help me one small line now? Please listen. This relocatable low level language or machine language or assembly language, this is the input to. Right? One more person. What is the name of that person? That person name is called as this one. Linker. Can you help now? Linker input, relocatable low level language or relocatable machine language, relocatable assembly language. That is the input to the linker, right? Now see this one. Output is going to be see this one, single relocatable low level language or machine language or, right, assembly language. Single relocatable low level language or machine language or assembly language. Some people are asking, what is the meaning of single, right? When you say linker, you are given, see this one, you are given so many things to linker. What the linker will do is, the things which are associated, you will make it as one. Linker, you are given many things you are given to the linker. Linker don't take all, right? You will take out of, you are given 100. Out of those 100, only 50 are related to you. Those only you will bring. Which project you are running, that project all associated things you will bring to the next stage. Suppose linker is not there, filtering out is very difficult. Linker knows to, right, to execute this project. Supposition that here supposition that so many files are there, so many relocatable low level language files are there. So many are there. Suppose that 100 files are there, which are relocatable. Out of those 100, the program which you are running, the program instead of saying program, the project which you are running, 100 files are there. The project which you are running to that project, which are associated out of that 100, isn't that 90 are associated? You will make all the 90 as, right, one. That is called single relocatable low level language. I have so many relocatable files here to my project to run, which are necessary. You will bring only those. You will make all the necessary things which are necessary, right? It will make it as one bundle, right? So one file, that is called a single relocatable low level language. It is something like this one. Let me give this example also. It is something like this one. You are Indian, you want to go to US, right? You got the visa also. You have flight ticket, you got the visa, everything ready. Tomorrow your flight. Today night most probably what will happen? Right? I think tomorrow morning your flight is there. Everything you have. Today night, if my guess is correct, in your house, right? Packing is going on. Packing is called as linking. Packing is going on, linking. What is the meaning? All the things related to you, they will keep in one bag. Right, you are the person who is going from India to US, you got the visa also, you have flight ticket also, tomorrow morning flight, today night in your house, if my guess is correct, right, in your bag, all the things related to you, they are keeping. What is the reason? Suppose in that without packing and all, if you go directly, after going to US, you got to know that something is missing. Again, you have to come back, right? Again, you have to take that one, again you have to go, lot of expenditure and all. What is the best idea? Before going, just to do packing. One day before, just to do packing, so that all the associated to you, they will come inside that bag. Just make the right proper locking and all. Then you go. If you go to the US, right, all your things are with you only. No need to come back also. Otherwise, coming back is definitely costly. Some people are asking, that is costly, coming back is costly. But what is the costly here? What is the answer? Everyone after compilation is over, you have to go to running. Running means you have to go to main memory. Right? I think processor is running your program, which is there in the main memory. Now, while running, right, the program which is there in the main memory while running, you got to know that, right, processor got to know that one file missing. Again, you have to come back to hard disk. Again, you have to go back. Until that time, processor is waiting. Right? I think processor time you are wasting. Right? Without linker, if at all one file is going and running by the processor, in the main memory, right, while running, processor got to know one file is missing. To complete that project, right, to run that project by the processor, actually 20 files required. You took only 15. While running, processor will identify these 5 files are missing of this project. Right? Again, project running is stopped. You will come back to, right, hard disk, and you will take them and going back. I think definitely some time is wasted. What is the best idea? While going from hard disk to main memory, right? First of all, before going, just to do linking. Linker will do that. Can I say linker? Linker input. Many relocatable files. Many relocatable low-level language files. Many relocatable low-level language files. That is the input to the linker. Output is going to be single relocatable low-level language file. What is the meaning? I think out of those 100 relocatable low-level language files, what he will do is, which are necessary to this project. Isn't that out of 100, 80 only necessary. So you will make 80 as one bundle, right? So you will make one pack, right? This is going to be single relocatable low-level language. Now can you help? Linker input, what is the answer? Multiple. See, sir, multiple. multiple relocatable low level language files. Can you help me one small line? So listen, whenever one project is compiling, that project contains so many files. Right? Those all will be compiled. Those all will be sent to assembler. So when all will go to assembler, what will happen? Multiple relocatable low level language files will come. It is also same, right? Whenever you are compiling any project, that project contains so many files, right? So when you compile all those files, what will happen? Multiple low level language files will come. Please be careful. Here also, multiple pure high level language. Project internally contains so many files. I have a project which is the high level language. Project which internally contains so many files. After compilation, what is the answer? Low level language files you will get, but multiple, because that project contains so many files. Those are sent to the assembler. Multiple relocatable low level language files you will get. But when you give to the linker all necessary things, isn't that 100 there? Out of those 100, only 99 are necessary. 99 only will make it as single relocatable. You know very well who are associated, who are not associated. Who are necessary while running, who are not necessary while running. Whichever necessary while running, you will make it as single file. That is going to be linker. Next one, I think whenever linker step also over, what is the answer? Everything ready, packing, this one. I think this is over means what? Visa is available. This is over means what? Packing also available. Everything available. Now you have to go to from India to US. Then what is the answer? How it is? What is the meaning of India to US here? What is the meaning? Hard disk to main memory. That is called loader. That is called as loader. Loader will load the program. From hard disk to main memory. Now, can you help me? After loading is completed, where is your program? After loader is completed, where is your program? Single relocatable low level language file. Where it is now? It is there in the main memory. Because it is ready. To run. Right? This is called as normally people used to call it executable file. It is ready to execute. Until now it is not ready to execute. When loading also over, now your program will go to main memory, indirectly saying that I am ready to run. Means it is called executable. Can you help me one small line now? This is the way a particular language will be processed. This is the procedure a particular language will be processed. How? Can you help me? What is the first step? I have a program. At least carefully listen now. Can you help me now? What is the first step? You have a program. You said compile on that program. What is the first step? Program means what? High level language program you have. You say compile. First what will happen? Pre-processing will happen. Pre-processing is over. All shortcuts are over. Now you got the pure high level language. That is input to the compiler. What a compiler will do? It will convert high level to low level. Some people are asking, what is the meaning of high level to low level? I give an example also. It is a high level, it is a low level. Some people are asking, what the preprocessor will do? I explained this also. Right? I think he will replace this one. He will delete this. Right? First of all, he will replace. What is that one? It is the actual, it is the shortcut. Wherever shortcut there, he will replace by actual. After all replacements are over, this line will be deleted. So I given the note also, preprocessor don't do any calculation, but it will do only substitution. Right? Everyone know preprocessor purpose also. It went to the compiler. It will give low level language files or machine language file or assembly language file like that. But one thing, multiple will come. Why? A project contains so many files. Multiple. All will be compiled. A project contains 100 files. 100 files will be compiled individually. So 100 low level language files or 100 machine language files like that will come. They all will be given to assembler. Assembler will convert all low level language files into relocatable low level language files. But one thing, multiple only. 100 files are coming. Your project internally contain 100 files. All. Next one, I will give to linker. If at all are necessary, then all will come as a single. Suppose in the few are not necessary. While running, linker got to know that. File number 5, file number 6 really not required. You will leave it. Remaining things you will take. You will make it as single file. Now you got the single relocatable low level language file. Or single machine language file like that. Now, I think when you came here, everything is ready. But now your program is there in the hard disk only. If you want to run by processor, it should go to main memory. Then give this particular files to the loader. Loader will move your program from hard disk to main memory. Now your program is there in the main memory. Then I can say that your program is ready to execute. This is called as executable. This is called as executable. Means what I want to say directly. If you say compile, this much story will happen. If you say compile, this much story will happen. Now I given one example also for preprocessor. I written the note also what the preprocessor will do. I given the example also how the high level language look like, how the low level language look like. Normally people will think that if you say compile, directly compilation will happen. No, these many things will happen. This story is called as language processing. This is the way how a language will be processed. Let me make one like, see this one. This entire story. This entire story is known as, this is the way how language will be processed. Language processing. Right? This is the way a particular language will be processed. This is called language processing will be done like this. Now listen now. When you say a particular language is, a particular program is compiled. Not only this, many are there. So this is the way a particular language will be processed. It is called language processing. This is the way how it will be done. Next one, see this one. In this language processing, a particular language is how compilation process will be done. In this language processing, right? So after compiler, whoever will come. In this language processing, after compiler, whoever will come. Right? Whoever will come. After compiler, whoever will come. Right? These are, right, assembler, linker, loader. These are known as cousins of compilers. In language processing, after compiler, whoever will come, those are known as, right, cousins of compiler. In language processing, after compilation, whoever will come, those are known as cousins of compiler. Those are assembler, linker, loader. Right? Please be careful. Listen everyone now. Those people who don't listen this story, those people, right, who don't know this story, they will think that compile means compile only will happen. No. Compile means, right, before compilation small work, after compilation small work. But major work is compilation. Compile means compile will be done, that is okay. But before compilation little bit, after compilation little bit. This total story is called as language processing. Right? In language processing, after compiler, whoever is there, those are known as cousins of compilers. They may ask you, who are the cousins of compilers? Assembler, linker, loader. In the linker and loader, who will be done first? Right? Linker first. After linking, right, you have to load. If you load and link, time consuming. First link it, right? I think all the things came, then go for the loading. If you do that, right, lot of time will be saved. Right? Loading, while running something is missing, again coming back, again linking. Right? I think this may not be good idea. First link, then go for loading. So see this one. Listen, until now I discussed. Language processing will be done how? This is the way. Some people are asking what is the preprocessor purpose. I explained. What is the output of the compiler? What is the input? Right? This is the input, this is the output. Assembler purpose, moving the code wherever you want. Relocatable, what is the meaning? You can relocate wherever you want. Without assembler, if you do, it may not be possible. If at all possible, there may be a data loss. Next one. So many files are going from hard disk to main memory. Best idea, instead of moving all the people who are associated to that project, those only you move. That's what the linker will do. If linker is not there, many files may go from hard disk to main memory. Unnecessary things also may go from hard disk to main memory. After linking is over, then go for the loading. Loading is over, then it is called as executable. I hope until now you are okay, right? Let's see the next one. See the next one now. What is our major story? Introduction to compiler. Our major story is introduction to compiler. So language processing you done in that main one. Language processing we done. In that main one is going to be this one. See this one. In that main one is this one. right? Pure high level language is input, output is going to be multiple low level language, this one. How compiler will work? This is our major story, right? Let me go here. Now see how compiler, right? So please listen now. From now onwards, please be careful. See this one. See everyone. You only say compiler is a software or hardware. You only say compiler is a software or hardware. Compiler is a software, means it is a program. It is a program, but one thing, it is a software, it is a program, it's okay. But converting high level to low level. So lot of work is there. It is a program, it's okay. Lot of work is there. Because of lot of work, so many lines of code. Almost like 10 lakh lines of code. Compiler is a big software which contain approximately 10 lakh lines of code. Assume that compiler is a one program. Compiler is a one function or one program, whatever it may be. See this one. Compiler is a one program. To this program, input is going to be high level language. Compiler is a one program. To this program, input is going to be high level language. If you want, you can write pure high level language. Compiler is a program which will take high level language as input, right? Output is going to be low level language. Output is low level language or machine language. You know very well. Next one, assembly language. Right? To this big program, input is going to be pure high level language, output is going to be low level language. As I mentioned to you, because of it is a very big program which contains 10 lakh lines of code, you cannot write the total 10 lakh lines of code in one function. So what happened is internally, those 10 lakh lines of code will be divided into 6 parts. First part name, they kept the name as lexical analyzer. Those 10 lakh lines of code, they divided into some functions. In programming terminology, they are called functions, right? In programming language, they are called function, right? In compiler terminology, that is called phases, right? Phases, right? It is the first phase of the compiler. In the compiler is a big software. In that software, it is the first function. In programming terminology, it is the function, right? In the compiler design terminology, it is a phase, right? It is the first phase of the compiler, right? It is the first phase of the compiler. What is the meaning of the first phase of the compiler? As soon as you say, compiler started compiling. After preprocessor, this is the first thing which will going to be happen. This compiler program, total program contain 10 lakh lines of code, which internally contain some functions. This is the first function, name is called lexical analyzer. This is the one which going to be happen starting. This is the starting of the compilation. Some people are asking, after lexical analyzer is over, what is the next phase of the compiler? Syntax analyzer. Afterwards, I will write it clearly. Syntax analyzer is the next one. Semantic analyzer. Next one, intermediate code generator. Next one, code optimization. Next one, target code generator. It is the last one. Total compiler code contains 10 lakh lines of code. Those 10 lakh lines of code will be divided into 6 functions, right? First function is lexical analyzer. Next one is syntax analyzer. Next one is semantic analyzer. Next one is intermediate code generator, code optimization, and target code generator. So target code, what does it mean? Final code generator. Final code should come. That is called low level language code or machine language or assembly language. Please be careful. So compiler contain how many phases? 6 phases. 6 phases or 6 functions. Main function name may be compiler, which will take this as input, which will produce this as the output, which internally contains 6 phases or 6 functions. Right? Please be careful. Next one. Some people are asking. See the interesting thing. Some people are asking, sir, whenever compiler is, listen, whenever program is compiling, all these 6 functions are running. It's fine. Whenever compiler is compiling, all these 6 functions are running. We are okay with that. But one thing, whenever program is compiling, all these 6 functions are compiling. That's okay. But that time, suppose I have something I want to store, where I will store, right? If you have something, whenever compilation is going on, means these all 6 people are compiling, that is fine, right? That time, if you want to store something, where will you store, right? I think there is one data structure whenever compilation is going on. If you have something, if you want to store, you can store in that data structure. That is called symbol table. That is called symbol table. Whenever these people are running on the given program, compilation is going on means all these 6 people are running on that particular program. At that time, these people want to store something. Where they will store? Right? Whenever compilation is going on a particular program, means these 6 people are running. That time, if they want to store something, they can store in symbol table. They can store in symbol table. Some people are asking, sir, who can store? Lexical analyzer also can store. Syntax, anyone can store. While compilation is going on, means on that program these 6 people are running. That time, any one of these people are all, right, they want to store something. Where they will store? They can store in symbol table. They can store in symbol table. Please be careful. Some people are asking one more interesting thing. Whenever compilation is going on a particular program, mean these 6 people are running, it's okay. But that point of time, unfortunately some error came. To whom they will inform? They can inform to one more person is there. That person name is called as error handler. They can inform to error handler. Compilation time, at anything if they want to store, they can store in symbol table. Who can store? All these 6 functions. On a particular program, compilation is going on, means these 6 people are running. That time, if they want to store something, right, they can store in symbol table. That time some error is came. If they want to inform, they can inform to error handler. Error handler will take the corresponding action. So from today onwards, if anyone say to you, on a particular program, compilation is going on. What is the meaning? Compilation is going on a particular program is nothing but on that program, right? All these 6 people are running. That time, if they want to store, these people want to store anything, they can store in symbol table. That time, if anyone want to inform some error message and all, right, they can inform to error handler. So finally, before going to conclude this one, simply I want to say to you, compiler is a one complex program which contain approximately 10 lakh lines of code, which will take pure high level language as input, which will produce low level language as output. Because of it, the complex program internally contain 10 lakh lines of code, which is divided into, right, 6 functions, which are also called as 6 phases of compilation. Next one. Whenever a program is compiling, means on that program, right, these 6 people are running. That time, if they want to store something, they can store in symbol table. That time, if they want to inform any error and all, they can inform to error handler. Right? And one more, in the language processing, who is the major person to us? Compiler. How compiler going to be, right? What the compiler contain, what the input, what the output, what internally there, rough diagram I given. Right? Please be careful. This diagram many people know. In one of the previous paper, this question is there. The question is like this one. Right? Inside symbol table, who can store? This is the last year question. Inside symbol table, who can store? Who can store? All 6 people are having right. Whether they will store or not, I don't know. Everyone having the chance. Everyone have the ability of writing. Right? If they want, they will write. If they don't want, they don't write. What is there in that? But one thing, everyone have a right. Who can inform to error handler? Everyone. While compilation is going on, right? All these 6 people are running. I'm okay with that. That time they want to store something. They can store in symbol table. Right? Any problem came, they can inform to error handler. Right? Fine. I'm thinking you are okay. Now see the next one. See the next one now. See the next one. Some people are asking, sir, to understand exactly how the compiler is working and all, can you give one example? I am giving one example. Float x, y, z. X is equal to y plus z star 60. To explain how compiler exactly working inside, how compiler exactly working inside, right? I took one example, I will explain. Please try to get this example. If you can get this one, you will get the compiler, right? I think more clearly. So until now you got some idea, right? Internally inside a compiler, how many phases are there? 6 phases. You should know how they are working also, right? If you can listen this example, you will get some clarity. You will get some clarity. Let me explain now. Let me explain. See, I took one example. Float x comma y comma z. X is equal to y plus z into 60. Try to remember, listen. Try to remember. Explaining many statements will take a lot of time. What is my concentration? You see this one. I want to explain this statement only. How compiler is working on this statement I will explain. Second statement. First statement only for namesake I written. Only for namesake. If I write directly, you may ask me what are the data types of x, y, z and all. That is the reason I written. So listen everyone now. My goal in this problem is going to be how this statement will work. How this statement will be done by compiler. How this statement will be done by the compiler. Not the first statement. Second statement is our concentration. Second statement is our concentration. Please be careful. Right. How compiler is working on the second statement I want to take care. So not first one. Only for namesake I written the first one. Right, fine. This one please take care. Now listen. Listen everyone, interesting answer. Interesting answer. So this is the input. See this one. When you say compile this statement. When you say compile this statement, who is the first person? Who is the first person will come to the picture? Inside a compiler, first function is going to be lexical analyzer. It will go to lexical analyzer. Right? When you say compile this statement by compiler, means it will go to lexical analyzer because it's the first phase of the compiler. Right? It will go to the lexical analyzer. What it will do, I will explain within few minutes. Now listen everyone. How this statement is working, internally by compiler, if you want to know, see this one, see interesting answer. How this statement is working by compiler internally, if you want to know, right, try to remember, you have the ability of compiling, if and only if, inside your system, compiler should be installed. You want to compile this statement? Yes. Then in your system, first of all, compiler should be installed. Without installing compiler, you cannot compile it. If you want to, listen everyone now, if you want to compile on any program of any language, right, definitely in your system, that compiler should be installed already. Otherwise, you cannot do that. Because you don't have that compiler means, how can you compile that particular one? You have compiler of that particular language, then only you can see that. Now can you help me one small line? This statement I want to compile. What is the meaning? In my system, already this language compiler should be there. Whenever you install that language compiler inside your system, your system got to know about that language very well. Your system got to know about that language very well. So once again I am asking you, I have some program. I want to compile that program. What is the first thing should be done? Right, that particular language compiler should be installed. Then only your system knows, right, about that language, all the things. If you don't install that compiler, definitely you cannot compile that program. Please be careful. Can you help me one small now? This particular statement I am compiling. What is the meaning? In my system, already this compiler is there. What is the meaning? My system knows about this language very well. Because if I installed, that my system now got to know so many things. Some people are asking, before installing this compiler in your system, after installing this compiler in your system, what is the difference? What is the difference? Without installing, my system don't know in this language, right, what are the data types are available. In my computer, I didn't install this compiler. What is the meaning? My computer don't know in this language what are the data types. My computer don't know in this language what are the operators allowed. My compiler don't know in this language what are the operators priorities and all. My computer don't know in this language what keywords are available. So if you compile, listen everyone now, if you compile without compiler, you don't know anything. Supposition that you install, right, that language compiler in your computer. What is the meaning? You got to know what are the data types are available, what are the keywords are available, right? All the rules and regulations you got to know. If you install, if you don't install, this is the difference. If you install, about that language, you knows many things, right? If you don't install, nothing he knows. Definitely some problems will come. Right, please be careful. Now listen now. I am compiling this in my system. What is the meaning? My system already contain that compiler already installed. Please be careful. I'm starting now. If I give this statement to the lexical analyzer, right, then how he will behave, I will check. See this one. How he will behave, I will check. See the answer. How he will behave. Listen everyone now. How he will behave. So when I give this statement to the lexical analyzer, because of already inside my system, inside my computer, already, right, that compiler is installed, what the lexical analyzer will do is, see this one, he is having some rules and regulation. Careful listen. He is having some rules and regulation. Everyone, a lexical analyzer is a program. Program is nothing but rules and regulation. He is having already some rules and regulation. According to those rules and regulation, he will go inside this particular program. He will do like this one. See this one? He will ask this person, who are you? Right? Lexical analyzer having some rules also. Through rules, he identified that X is the identifier. He identified. X is the identifier. He is already identified. So he is having some rules and regulation. Through regulations, he got to know that it is the identifier. Identifier means what? Variable name. Who are the identifier? Variable name, function names are normally known as identifiers. Some people are asking in the programming language which are known as identifiers, right? Variable names and function names known as identifiers. Now can you help me now? When I give this statement to the lexical analyzer is a program which is nothing but some condition. Using those conditions, right? He will go and he will verify. He got to know that it is an identifier. This is also identifier. Please be careful. He got to know that. And one more thing. Please listen. This is also interesting thing. Please listen. Right? Identifier. Listen everyone now. Identifiers all will store in symbol table. What is the reason? I will say afterwards. Identifiers will store in symbol table. Please be careful. From today onwards, if anyone asks you what symbol table contain, what will you say? Just say identifiers. Symbol table contain identifier. It is a sequence number. It is a variable name or function name. Just as of now I have variables, I am writing only variables. Variable name. Next one, variable type. Symbol table contain identifiers. Identifier means function names and variable names. I am writing here only variables because here no functions are there. Right? Fine. Now see this one. See everyone now. Sequence number. Serial number or sequence number. 1, 2, 3. Can you help me now? What is the first variable name? X. Type float. Next one. What is the second variable name? Y. Type float. What is the third variable name? Z. Type float. Symbol table. Can you help me? From today onwards, if anyone asks you, when our compilation is going on, right, you want to store something, where will you store? What is the answer? Symbol table. Next one, what does the symbol table contain? What will you say? Variable names and function name. These are called identifiers. Identifiers will store inside symbol table. Identifiers along with its information. What is the meaning of identifier along with its information? What is the meaning? Variable X, type is float. Variable Y, type is float, right? Once again I am asking you, right? Compilation is going on, right? All the 6 functions want to store something. Where they will store? Symbol table. What does the symbol table internally contain? Identifiers. Identifier means variable names and function names. Right? Next one, symbol table contain identifiers along with its information. What is the meaning? Variable name is X, type also. Variable name is Y, type also. If it is a function, what it will store? Function name. Next to function return type. Next to function inputs. What is the function name? That function will take what inputs, that function will return what output, right? It will contain all. So symbol table contain identifiers along with its information. What is the reason? Only identifiers Y. I will explain within a few minutes. Don't worry, right? Now can you help me now? Lexical analyzer input, this one. And one more thing. Listen everyone now. In which computer you are compiling this one? Right? Already that computer contain compiler. When you say already that computer contain compiler, what is the meaning? That computer knows all the rules and regulations of that language. Please be careful. That compiler knows. Listen everyone now. When you are compiling any function in a particular system, first of all, compiler should be installed in that. Because of you installed, what is the meaning? That computer knows all the rules and regulations of that language. Right? In that language, right? First part is going to be lexical analyzer. Right? What is the meaning? That computer knows lexical analyzer code and everything. You installed means what? Lexical analyzer code is available. Using that code, right? You will try to do some work on that. Whatever this code will say, accordingly we will go and we will check. Can you help me one small line? Listen. Lexical analyzer will go. He is having some code. According to that code, he will ask. Right? He will get to know that he is a identifier. Some people are asking how lexical analyzer got to know that he is identifier. He is having some code. Right? He will check that code is on this. He got to know it is a identifier. Next one, listen everyone now. Next one, lexical analyzer will apply that code on this person also. Lexical analyzer got to know that it is a assignment operator. Lexical analyzer will apply that code whatever he is having on this also. He got to know it is identifier. Like that he will do. So he will go to everywhere. He will identify who is he. Can you say who is he? Identifier. X is a identifier. Some people are asking how that computer knows what is the code of lexical analyzer. You are already installed. That computer knows what is the lexical analyzer code. Using that code he will apply here. He got to know that with that code it is an identifier. And one more interesting answer. See this one. One more interesting answer. If at all he is an identifier, careful listen. Lexical analyzer got to know that he is identifier. It's okay. If at all he is identifier, he should be there in the symbol table. He should be there in the symbol table. Can you help me one small line? In the symbol table, which row X is there? I think first row. So now see what will happen. Lexical analyzer got to know that he is an identifier. If at all he is identifier, he should be there in the symbol table. In the symbol table, which row is there? First row. Then what the lexical analyzer will do is, he identified it as it is an identifier. Fine. So not only identifying, it is identifier. He will give one token number also. What is the token number? In the symbol table, he is there in the first row and he is identified. He may give like this one, ID1. ID1. It is a token number. Now again, if anyone asks you from today onwards, what is the lexical analyzer purpose? Right? He will identify. Right? He will identify. Right? Who is he? He will identify who is he. Some people are how he will identify. He is having code. Using that code, he will identify. After identifying, he got to know that he is identifier. If at all is identified, he should be there in the symbol table. Yes, which row is there? First row. So ID1, he will give token number also. What is the meaning of ID1 indicate? He is identifier in the symbol table first row there. Right? Fine. Like that. Next one. See the next one now. Lexical analyzer will apply the code whatever he is having here. He got to know it is a right, assignment operator. Let me write now. Assignment operator. Operator, if you want, I will write operator. Okay, fine, it's okay. Assignment operator. Assignment operator. An interesting thing, you don't give token number for this. Right? Only for identifier, he will give token number. For other people, you don't give token number. For identifier, he will give token number. Right? Lexical analyzer will give token number only for identifiers. For other people, you don't give token number. Some people are asking, sir, why? Why he will give token number only for identifier? Why not for others? What is the answer? Symbol table contain only identifier. If symbol table contain only identifier, right? For the operator, how can he give token number? The people who are there in the symbol table, for them only token number. For other people, no token number. Now let me say clearly here itself. Some people are asking, assignment operator, why token number not required? See this one. See everyone now? Listen everyone now. Right? Listen everyone now. That compiler knows very well it is an assignment operator. That compiler knows very well it is an assignment operator. Every compiler knows what operators he is having. Every compiler knows, right, what keywords are there. Definitely C compiler knows, C compiler knows, right, all the keywords of that language. C compiler knows all the operators of that language. Some students are asking me, right, the people who are there in the symbol table, for them only token number. What is the meaning? Only for identifiers token number. For other people, no token number. What is the reason? Let me say this one. First of all, why are you storing only identifier in the symbol table? Get the clarity for that. But one thing is to whoever is there in the symbol table, for them only token number. For other people, no token number. That's the first point. Next one, why are you storing only identifiers inside the symbol table? Why not others? Let me check here. Listen, let me check. When you install compiler, assume that C compiler you installed inside your system. Assume if C compiler if you store inside your system knows, right, which is the addition operator, because C language, every language is having some operators, Right? When you install C compiler inside your system, now your system knows, which is the addition operator, which is the subtraction operator, which is the multiplication operator, what are the data types available. So your system knows everything about C language. But one thing is true. In C language, fixed operators are there, fixed keywords are there. You cannot create whatever keyword you like. You cannot create whatever operator you like. Please be careful. Right? So every language having some operator list. Every language having some keyword list. Is it right or not? So when you install Turbo C compiler inside your system knows what operators are allowed. Right? What keywords are allowed and all. But one thing is true. Right? Your system don't know. What variable names are they? Because user can give variable whatever he want. User can give variable name whatever you want. See this one. Listen everyone, no compiler knows what are the variable names. No compiler knows what is the function name, because user can give whatever variable name he like. User can give whatever function name he like. Right? User cannot take whatever operator he like. What is the reason? Already Turbo C compiler having some operator list too. Those only you can take. Already Turbo C compiler having some set of keywords. Those only you can take. But user have the ability of taking the variable name whatever you want. The things which are not fixed, right? They will be stored inside symbol table. Please be careful. Symbol table contain all user related things. Right? Turbo C compiler contain all language related things. Turbo C compiler knows already which operators are available to him. Already which keywords are available to him. That is the meaning of installing. When you install Turbo C compiler inside your system, it knows what operators you can use, it knows what keywords you can use, it knows what rules you have to follow, everything. But one thing, it don't know what are the variable names. Because, right, variable name, user can give whatever name he like. Depending upon program, see this one, depending upon program, variables will come. When you install Turbo C compiler, there is no variable names because there is no program. Right, program related things are variables and function. So, right, language related things are operators. Right, all the language related things are already in Turbo C compiler. What are the things available? Operators. Next one is keywords. Right, that is the reason. Can you help me one small line now? Why variable name is stored in the symbol table? Right? Why variable name is stored in the symbol table? What is the answer? It is related to program. In program only these variables will come. But one thing, this assignment operator and all, these are already there in Turbo C compiler. But variable names are not there in Turbo C compiler. Variable names are there only in program. These are user related things. All user related things will store in symbol table. All language related things will store in the Turbo C compiler. When you know, why you give token number. When you don't know, new persons only give token number. New persons only. Every language know its operator. Every language know its keywords. For them, token number not required. New people, program to program, identifiers will change. For them, give token number. For them, store first two, then give token number. Some people are asking, sir, why don't you store operators also? They are already inside the Turbo C compiler. I installed means I already stored. No need to store again. Right? Fine. It's okay. What next? Next one, I think Y is a lexical and the rules are saying that Y is a identifier. Y is an identifier. Identifier means token number required. So can you help me now? In the symbol table, Y is there in which row? Second row. ID 2. So token number. Program to program, identifiers will keep on changing. For them, token number required. Program to program, operator list cannot change. Program to program, keyword list cannot change. So the things which are fixed, why are you storing? Because they are already stored inside Turbo C compiler. Why you want to store again and again? Next, why also completed. Next one, plus is the operator. Which operator? Addition operator. Because if it is the addition operator, it is there already. So it is already there in the Turbo C compiler list already. Addition operator. No token number required. Next, Z, which is again identifier. Again identifier. So what is the answer? I think ID 3. ID 3. Next, star is a multiplication operator. Star is multiplication operator. He knows very well. It is already stored in the Turbo C compiler inside. So you don't store again. You don't give token number because you know already. If you know already, why you give token number? Next, 60. 60 is a integer constant. Is an integer constant. Only identifiers. Only identifier it will store inside symbol table. So I think it is the right. It is the output of the lexical analyzer. Let me write the output once in one line. Let me write. What is the answer? Let me write in one line. Can you help me? X means token number. From now onwards, in the place of identifier, their token number will go. What is the X now? ID1 is equal to. For this one, there is no token number. Is equal to what is the answer? ID2. Next one, ID2 next plus ID3 into 60. Now I think, see, whatever you understood, it's okay. Let me ask you one small line now. Lexical analyzer, listen, lexical analyzer input. Lexical analyzer input, high level language statement, output. I am repeating once again now. Lexical analyzer input, high level language statement or high level language string. Isn't that it is a string? Lexical analyzer input is going to be high level language statement or high level language string. Output is going to be, listen, output is going to be token string. This is called token string. So if anyone asks you from today onwards, lexical analyzer purpose, dividing the given, listen, dividing the given string into tokens. Dividing the given string into tokens. That's the purpose of lexical analyzer. How he will divide? He is having some rules. According to rules, he will divide. Lexical analyzer having some rules. Based on those rules, he will divide. Right? Now again I am asking, lexical analyzer input, high level language string, output, token string. If anyone asks lexical analyzer purpose, dividing the given program into tokens. And one more, for every person, for every token, will you give token number or only few? Only for identifier token number is there. They only are in the symbol table. What is the reason? They are not stored anywhere. Program to program they are keep on changing. They will be there. They will be there. That program symbol table. Every program having one symbol table. Whenever you are compiling one program, to that program symbol table will be created. There, listen everyone now. Identifiers are belongs to program. Whenever program changes, identifiers will change. But whenever program changes, operator list cannot change. Operator list will change language to language. One language to another language, operator list may change. Keyword list may change. But one thing, program to program, identifier list will change. To this program, who are identifier, they will store inside symbol table. Remaining all, they are there. When you install that language in that system, in that particular installation, already remaining things are there. Why you want to store the same thing many times? Operator is there inside Turbo C compiler. Why you want to store inside symbol table also? It is unnecessary. New things you store. Program to program, new things are identifiers only. Only identifier will store inside symbol table. For them only given token number. Can is output of lexical analyzer? Token string, input, high level language string. Fine. Some people are asking, sir, how tokenization will be done by lexical analyzer? He is having rules. When you go to the lexical analyzer chapter, there you will see. He is having some rules. Based on those rules, he will divide. While dividing, he got to know the identifier. In the symbol table, he will take the number, he will create the token. So for all identifier, he will give token. For other people, he don't give because everyone knows. Everyone know about other things. No token number required. Only for new things, token number required. Fine, I'm thinking it's okay. So input output of lexical analyzer, little bit clarity if you get, it's okay. Little bit clarity enough. Next one, can you help me now? This is the input to. Who is the next phase of the compiler? This is input to the syntax analyzer. Now carefully listen this. See this one. S goes to ID is equal to E. E goes to E plus T or T. T goes to T star F or F. F goes to ID or int. S goes to ID is equal to E, E goes to E plus T or T, T goes to T star F or F, F goes to ID or into. Can you help me now? Syntax analyzer input, token string. What is the output? I will explain. See this one, input is token string. What is the output? I will explain. See this one, see carefully. Careful listen. S goes to, this is the grammar. This is the grammar. Please be careful. This is the grammar. Right? Now from this grammar, see, listen everyone now. This is the grammar. From this grammar, I want to generate this string. Syntax analyzer input is going to be token string. What is the output? Output is going to be tree. Output is going to be tree. Using this grammar, can I generate this string or not? Let me check. Using this grammar, can I generate this string or not? I will try. See, this one, S goes to id is equal to e. S goes to id is equal to e. E goes to e plus t. T goes to t star f. F goes to int. T goes to f. F goes to id. E goes to t. T goes to f. F goes to id. Listen everyone now. Syntax analyzer input is going to be token string. Output is going to be syntax tree. This is called syntax tree. From some people are asking me, what this syntax tree contain? What is the answer? Using this grammar, I drawn this tree. Using this grammar, I drawn this tree to generate this string, to generate this token string. Some people are asking, sir, where you generated? Let me check here. In this tree, read all leaf nodes. If you read all leaf nodes from left to right, in this tree, read all leaf nodes from left to right. What is the answer? id is equal to id plus id star int. id is equal to id plus id star int. Can you help me one small line now? See this one, to this one input is going to be token string or not? Can you see in the token string what is the first one? In the token string what is the first one? id means identifier. What is the identifier token? id1. id means identifier. So in this place one identifier should be there. Yes, there id1 is equal to what is the answer? id. id means identifier. id2 token number I am writing, nothing there. id2, next one, id2 plus id3, right? id means id3 star into, can you help me now? In the place of into, what is there? 60 there, right? 60, right? 60. Now can you read in this particular tree, read all leaf nodes from left to right. What is the answer? id1 is equal to id2 plus id3 star 60, right? Now some people are asking me, syntax analyzer input, token string, output, syntax tree, syntax. Some people are asking me one small line now, right? Some people are asking one small line. The line is like this one. If I want to create syntax tree, I should need grammar. From where grammar is coming? Try to remember this one. Syntax analyzer is a function. It is having some code. Inside that some code is this only. This is written in the form of program. When you say compiler, listen, right, it is a very big program which internally contains 10 lakh lines of code, right? So syntax analyzer contains this kind of code. Some people are asking, sir, how to write this code? Somehow they will manage, nothing there. Somehow they will manage. So lexical analyzer also having some condition. Syntax analyzer also having some condition, right? This is the condition. Everyone know condition means set of rules. Syntax analyzer rules, right? These are the rules. Some people are asking, syntax analyzer contain only these rules or some more? Many rules are there. Syntax analyzer inside contain many rules. Listen everyone now, grammar is nothing but rules only. Grammar is nothing but set of rules. It is a set of rules. So some people are asking, these are the rules for what? Listen everyone now, this grammar means set of rules. This grammar will generate set of all arithmetic expressions. Everyone know, it is the arithmetic expression. To this arithmetic, listen, this kind of arithmetic expression, inside syntax analyzer, grammar is there. This is the grammar. Necessary part only I written. Syntax analyzer internally contain so many grammars. You can say 1 lakh grammars are there inside syntax analyzer. Arithmetic expression purpose 1 grammar. Boolean expression purpose 1 grammar. Regular expressions purpose 1 grammar. Declaration purpose 1 grammar. Syntax analyzer internally contains so many grammars. 1 lakh grammars are there. 1 lakh grammars. Please be careful. I am saying approximately. Many grammars are there, I want to say. Can I help you one small one? Syntax analyzer internally contain so many conditions. Conditions are nothing but grammar. Grammar is nothing but set of rule. Rule means condition. Right? I am repeating once again. Syntax analyzer internally contain so many grammars, means so many rules are there. So many rules. Arithmetic expression purpose, one rule. Means one grammar. Regular expression purpose, one grammar. Declaration purpose, one grammar. For loop purpose, one grammar. While loop purpose, one grammar. Speech statement purpose, one grammar. So for everything in the syntax analyzer, grammar is there. So this is the built-in grammar. This is the built-in grammar. See this one. Which expression is coming? Which expression? Arithmetic expression. So arithmetic expression grammar I written. It is internally there. Just I want to give rough diagram. Anyhow, listen. If anyone don't know what is going on and all, in the syntax analyzer, anyhow you will see that. Syntax analyzer, anyhow you will see that. See, listen everyone, every function having some code. Code is indirectly, directly some conditions only, everyone know. So syntax analyzer having some code or some rules, which are nothing but grammar productions. Now I think it's the correct time to ask you. Can you help me now? How many people will go? How many people will go? Syntax analyzer input is going to be string, token string. Output is going to be syntax tree. Yeah, listen everyone now. To generate syntax tree, two things required. String also required, grammar also required. String is this one, this is the input. String is this one, this is the input. Right? Output is going to be tree. But to get the output, right? Grammar required, grammar is built in. Syntax analyzer means grammar only. Syntax analyzer means grammar only. Now I think it's the correct time to ask you. Syntax analyzer purpose. What is the answer? Using this grammar, can I generate this string or not? He will verify. Listen everyone, using this grammar, can I generate this string or not? Some people are asking, this grammar means what? Arithmetic expression purpose, this grammar is there. Arithmetic expression purpose, this grammar is there. Using this grammar, can I generate this arithmetic expression or not? He will check. So if at all possible, what is the meaning? Tree will come. If not possible, tree will stop in between. Right? If not possible, tree will stop in between. Now I think it's the correct time to ask you. Syntax analyzer input. What is the answer? That syntax analyzer input is going to be, what is that one? Token string, which is the arithmetic expression. Token string. Output is going to be syntax tree. And one more. Syntax tree is possible or in the middle stopped. Possible. What is the meaning? Possible means no syntax error. And one more thing I want to ask you. Can you help me now? Syntax analyzer for arithmetic expression. Syntax analyzer for arithmetic expression. Right? What will change? This string will change or grammar will change? Grammar is fixed. Syntax analyzer, arithmetic expression, this is the grammar. Syntax analyzer, arithmetic expression, this is the grammar. String will be keep on changing. Arithmetic expression keep on changing. Program to program, right? Arithmetic expression will keep on changing. Right? Now supposition that in a particular program, for this arithmetic expression, right? Using this grammar, tree possible or not verified. Possible means no syntax error. Not possible, what do you mean? In between stopped. Syntax error is there. Syntax error. And one more. To draw the tree, string required. Grammar also required. Listen everyone, syntax analyzer actually required two inputs. One input is going to be what you are generating, means this string. Using which grammar? This grammar. Because of this, the built-in, I am not giving input. If it is not built-in, I could have given that. It is a built-in. Syntax analyzer means inside there is a rule. There are rules. Many rules are there. So actually for every, listen, this is also called as a parser. Syntax analyzer, another name is parser. Parser is nothing but creating parse tree. Can you help me now? Syntax analyzer, another name, parser. Parser purpose, creating parse tree. To create parse tree, what are the necessary things? What you are generating means this string, using which grammar? Suppose the built-in not there, I will give. Built-in is there, that is the reason I am not given. So using built-in grammar, can I generate this string or not? He will verify. If it is possible, tree will come. If not possible, tree will not come. Okay, whatever you got, it's okay. It's the correct time to ask you. Lexical analyzer input, high level string, output, token string. That is the input to syntax analyzer. Syntax analyzer input, token string. Output is going to be syntax tree. This is the tree. Output is going to be syntax tree. This is the tree. Right? Please be careful. Syntax tree. Some people are asking syntax tree in between stopped. What is the meaning? From the given, from the available grammar, right? The string which you are given, not possible. What is the meaning? I think syntax error. Can you help me now? Grammar is wrong and string is wrong. String only wrong. Grammar cannot be because it is a built-in. It is a built-in grammar. Using built-in grammar, you are unable to derive that string means in the program you written string wrong. That expression is wrong. That is called syntax error. Okay, whatever you got, it's okay. Can you help me now? Listen, the purpose of this introduction is going to be just identifying for every phase of the compiler, what is the input, what is the output. See, if anyone thinking that, sir, I am not getting clearly, if anyone thinking, that is the meaning of introduction. Introduction purpose, every phase of the compiler, what is input, what is output. What is input, what is output. If you get everything, well and good. If you don't get, don't worry. If you don't get, don't worry. Just identify for every phase what is the input, what is the output. Syntax analyzer, output, syntax tree. Input actually required. String also required and grammar also. Grammar built-in is already available. Grammar is built-in grammar already available. With that, can I generate that particular token string or not? If possible, then what is the answer? If possible, syntax error is not there. Otherwise, syntax error is there. Please be careful. Now, I am thinking that you are a little bit okay. Right, now see the next one. See the next one. This is the input to. This is the input to. Next phase of the compiler. Who is that? Semantic analyzer. Semantic analyzer. Right? So, to the semantic analyzer, input is going to be syntax tree. Semantic analyzer input is going to be syntax tree. What is the output? I will explain roughly. I will explain roughly what is the output. See roughly what is the output. Input is going to be syntax tree. I am okay. Output is what? I will explain. See this one? Output. S goes to, let me draw the same tree. I will explain one interesting thing is there. I will explain. ID is equal to E. E goes to E plus T. T goes to T star F. F goes to int. T goes to F. F goes to ID. E goes to T. T goes to F. F goes to ID. Right, like this. ID is equal to ID plus ID star, right, like this. Now, can you help me one small, same tree I am drawing. What is the answer? What is the reason for this? I will say ID1. This is the, I think, let me write those also. It is the ID1. This is ID2. Same thing I am writing. I am not writing, right, something new. It is the ID3. It is 60. Right? Fine. Everything is fine. Can you help me now? Semantic analyzer input. Semantic analyzer input. Syntax tree. That's okay. What is the output? I will say. Output also looking like a same tree only. But what is the change? I will explain. Input is going to be syntax tree. Output is also looking like a tree. What is the tree? What is the change? I will see now. Right? Let me check. See this one. Listen everyone. Listen everyone. S goes to, everyone listen this one. S goes to ID is equal to E. Can you help me now? S goes to ID is equal to E. That's okay. But what is the identifier? ID1. Right? So identifier, it's okay. What is the identifier token? ID1. Can you help me one small line now? ID1. What is the meaning? Is it token number or not? Yes. What is the meaning of ID1? In the symbol table, this person is there. In the symbol table, this person is there in the first row. Can you go to the symbol table? Go to the symbol table, first row, who is there? Who is there? First row. X is there, type is float or not? Now see this one. S goes to ID is equal to E. This is the identifier, it's okay. Token number is this one, that is also okay. In the symbol table, you will go in the row number 1, that person is there. Can you say row number 1, which person there? X is there, type is float or not? X is there, type is float. Is it right or not? Right? If you're okay, I think what is the data type? Float. X is the variable name, type is float or not? This one. S goes to ID is equal to E. So this is the identifier. Identifier means token number there. So using that token number, go to the symbol table first row. Please verify what is the variable name. X. Type is float or not? E is float. But everyone now, listen. It is the assignment operator. Left is float there. Right also should be float. Because if you want to do any operation between two people, both should have same type. Right, listen everyone, now between two people you are doing some operation, right? Definitely both will be same type. Please be careful. Right? I think let me ask you one assignment operator. What is the left? Float or not? Right should also be float. Let's check here. E goes to E plus T. E goes to E. It's something like program only. E goes to E plus T. Left. E goes to T, T goes to F, F goes to ID. ID means identifier. Identifier means token number is there. Using this token number, can you see the symbol table second row? Who is there? Symbol table second row, if you observe, Y type is float. Y type is float, right? I think this is also float. This is also float. See this one. To do this plus operation, left required, right required. Left you are going. So left is float. Can you help me now? Assignment operator left already float. Listen everyone now. Assignment operator left already float. I am trying for right also float or not. Let's check. E goes to E plus T. To do this plus left required. Left already float. See this one is float. Right? Same float will go here. This is finally float. That is fine. To do this plus left required, I think left float, right also go there. To do this particular, right, to get this one, T goes to T star F. To do this star, left required, right required, first left required, left come. Again ID. ID means identifier, right? Token number available, ID 3. In the symbol table, third row you check. Who is there? Z float. I think this is also float. This is float means same thing will go here. It is float. It is float. To do this star, left float. Right is what? Let's check here. Right is what? Let me check. But one thing is to do this multiplication operator, right? Two people required. Left already float. Right also float required. To do this plus left already float. Right also float required. To do this one left, right? To do this star left float. Right also float required. Let me check here. F goes to into. Right? I think left float, but right is integer. F goes to into. F goes to into. But is expected float. But what is came? Int came. What is came? Int came. Let me check one small line. Listen, let me check one small line. So, see everyone now. Here also float is expected. But what is there? What is there here? Here I think there is a int is there. See this one. Int is there. 60 is a integer. But he is expecting left float. Right also should be float. But float is not there. So he is expecting float. But unfortunately integer is there. But according to the rules and regulation, right? Both should be same type. Then what is the answer? Because of it is not same type, you have to do typecast. Let me do typecasting. I'm doing the typecasting. See this one? I'm doing typecasting. You know very well what is the typecasting. Let's check here. I'm doing typecasting. See this one? Integer. Careful listen. It is the integer 60. It is the integer 60. This is the available thing. Right? See. Typecasting you know very well. We done in the programming. See this one. This is the typecast. See the answer? Here you write. Right? Something like float. Just write float. Right? 60 of float. Then what is the answer? It will become 60.0. It will become 60.0. So actually int 60 there, you done the typecasting, float of 60, it will become 60.0. 60.0. Right? Now I think it will once again becomes float. Actually it is the integer according to the rules and regulation. Left float means right also float. Not there, not there. You done typecasting. So now after typecasting is over, left float, right also float. Finally it became float. Next one, left float plus right also float. This finally became float. Next one, left already float. This also float. I think there is no problem. Right? There is no problem. I think I'm just want to ask you one small line. Semantic analyzer input, syntax tree. Output also syntax tree. Modified syntax tree. Modified syntax. Some people are asking, sir, where is the modification? See, somewhere I done typecasting. Little changes are there. Right? Somewhere. Sometimes no modification. If everything is all right, why I will modify? Semantic analyzer input is going to be syntax tree. Output is going to be modified syntax tree. Output is going to be modified syntax tree. Right? Please be careful. Output modified syntax tree because here type is not matching. Right? Type is not matching. I done the typecasting. Why you done typecasting? If you want to do any operation between two variables, both will be same type. Left float, right also float required, but it is integer. You done the typecasting. And one more, listen, one more interesting thing. You done the typecasting, right? Small to bigger one, bigger to smaller one. 2 bytes to 4 bytes you done. 2 bytes to 4 bytes you done. If you store 2 bytes in 4 bytes, actually there is no problem. This is called implicit typecasting. Actually no problem means compiler will do. But one thing, whether compiler will do or you will do, it doesn't matter. If two are not same type, you have to do typecast. Both same type, then only operation you can do. Both not same type. Problem there, problem not there, you don't care. Both are not same type. You have to do type conversion. Suppose serious problem, user I have to do. Normal problem, you don't have that kind of problem. Serious problem not there, compiler will do. Here serious problem not there. Why? 2 bytes if you store in 4 bytes, same answer. But 4 bytes if you store in 2 bytes, serious problem. Because 4 bytes you are storing 2 bytes means something you will lose. You will lose means compiler don't do, because you will blame the compiler. You don't lose, then compiler will do. But one thing, whether compiler will do or user will do, we don't know. But someone have to do, because both are not same time. Now I think it is the correct time to ask you, semantic analyzer input, syntax tree, output, modified syntax tree. And one more, semantic analyzer purpose. I am not asking what are the input and output. I am asking what are the purpose. Semantic analyzer purpose is type checking. It will check the types are same or not. If not, typecasting will be done. Whether user will do or system will do, I don't know. Typecasting should be done if both are not same type. Semantic analyzer purpose is type checking. Please be careful. Can I help you know? Syntax analyzer purpose. Syntax errors checking. Syntax error checking. What is the meaning? Syntax tree possible. Syntax tree possible, no syntax error. Syntax tree not possible, syntax error is there. Syntax error is there. Please be careful. Can I say lexical another purpose? Tokenization. It will do tokens. It will divide the given program into, now I am taken one string only, but actual input is going to be lexical analyzer, actual input is going to be high level language program, big program. If I take big program, it will take a lot of time. That is the reason I am not taking the program. I am taking one statement only. Right? One statement, this is the story. One statement, there is a tree. If I take the big program, in that program for every line, there is a tree. X is equal to A plus, listen, X is equal to Y plus Z into 60. Further, this is the tree. If the program contains 1 lakh lines, for every line, there is a tree. For every line, there is a type checking. For every line, there is a tokenization. Please be careful. That is the reason. So those people who seen this entire incident, please be careful while writing the program. Unnecessarily don't write any line. If you felt unnecessarily, why you written? If you write unknowingly, unnecessary line, if you write unnecessary line, if you written unknowingly, for that tokenization, for that syntax tree, for that, right, type checking also. See this one, I think both will be same. Input also, output also same, modified parse tree or modified syntax tree, because somewhere types are not matching, so you have to do typecasting. If everything matching, same thing will be there. But he will do type checking. Please be careful. His purpose is type checking. His purpose is type checking. Please be careful. And one more interesting answer. Listen, one more interesting answer. How we know? Listen, very, very important line is coming. See this one. Very, very important line is coming. See this one. How we know? How we know? This identifier type is float. How he knows? How semantic analyzer knows that this identifier type is float? How you know? Using this token number. Using this token number. He will go symbol table first row. Using the token number, he will go symbol table first row. Symbol table first row, there is a float. Okay, this is float. Symbol table second row, he will go. There is a float. So this is float. Means what I want to say indirectly, right? While doing type checking, every person type required. Every person type required. To know that type, he will visit the symbol table. In the symbol table, he will check what is the type and all. Semantic analyzer, to do type checking, every time types are required, he will go to symbol table, and symbol table he will check what the type and all. Is it right or not? So what I want to say directly, in the symbol table, these types are stored by semantic analyzer only. Because he need it. Listen everyone, who is using this information? Who is using these types and all? Who is using? Semantic analyzer is using. Because of he is using, and he only should store. He only should store. Listen everyone, if anyone asks you from today onwards, in the symbol table, who is storing these all the types and all? What will you say? Semantic analyzer, you will say. Listen everyone now. Who need types? Who need types? Semantic analyzer. If semantic analyzer need types, he is the person who should store in symbol table those types and all. If anyone asks you, who can store inside symbol table? What is the answer you are going to give? Who can store inside symbol table? What is the answer? All. All can store. That's the first thing. Next one, suppose some people ask you, all it's okay, but can you say one person? One person I want. All okay, but most probably who is? If anyone asks you, one only select, then what is the answer? Semantic analyzer, because he want types every time. Every time C is the person, like semantic analyzer is the person, every time he scan the symbol table, every time he went, he need type here, he need type here, he need type. Actually, everyone stored inside the symbol table. If you want to select one person, whom you select? Semantic analyzer. Semantic analyzer is the one, right, who stored inside the symbol table. If you want to select one person, that is the story. Right? Please be careful. One more thing I want to say to you. One more thing. Can you help me now? Who is given this token number? Who is given this token number? Lexical analyzer. Suppose him that lexical analyzer is given token number, it's okay. Token number not there. How I know what the type of him? Isn't the token number not there? How I know? How I know what the type of this person? What the answer? Identifier. Listen, token number is not there. Identifier name I know. Assume that X. Right? Identifier name is X. Assume. Token number not there means variable name is there. So take that variable name because of token number not there. Directly you cannot go to that row. Only variable name is there, token number not there. So take that variable name, see the entire symbol table like this. Ask every person, are you X or not, are you X or not, like that. If token number is there, directly I will go to that row. If token number not there, total table maybe I have to scan. Can you help me using token number? Using token number, time is saved or not? Yes. Right, lexical analyzer is given token number so that using that token number, other phases can do the work easily. Other phases can do the work, right, little less time. That's the purpose of token. Can you help me one small line now? What is the greatest thing? What is the greatest thing lexical analyzer is doing? He is doing tokenization. That is one of the great thing. One more great thing is for identifiers he is given token number. Why? Using those token number, other people can access directly them. And they can do their work. So, like that, lexical analyzer saving some time of other pages. Suppose token number not there. Again, lexical analyzer, whatever way he done. Right? Syntax analyzer, semantic analyzer also. They have to check again symbol table again and again like that. Right? Fine. Okay. Whatever you got, it's okay. See this line also. See the interesting line. This line also. Listen, everyone, interesting answer. Interesting answer. Please see this one. So whenever semantic analyzer is checking the types and all, see this one. Assume that ID1, token number is ID1, right? So you want type of this one, careful listen. Semantic analyzer is doing type checking, that's okay. But whenever he is checking the type checking, see this one. You want type of this person. What is the token number? ID1. When you went to the symbol table first row, assume that here variable name is X is there, but here not there. ID1 means what? Symbol table first row is there. Yes, I came. Right? Variable name is there, but type is not there. Type is not there. See this one. He want type. That is the reason he went there. Right? Using token number event. But when I came to here, variable name is there, but type not there. But he want type. But type is not there. Immediately semantic analyzer got to know one interesting thing. What is that? Okay, type is not there. Indication that it is the undeclared variable. Indication that it is the undeclared variable. He want type, but inside symbol table, that person is there, but type is not there. He got to know that it is undeclared variable. And for undeclared variable, symbol table contain type as gap. Please be careful. Now I think it is the correct time to ask you. Please listen once. Please listen. Right? Semantic analyzer purpose. What is the major purpose? Type checking. What is the one more? Undeclared variable also you will calculate. Undeclared variables also you will calculate. Please be careful. And one more, who will store inside symbol table? All. If you want to select one person, semantic analyzer, because you need mostly symbol table. Next one, who will identify undeclared variables? Semantic analyzer. How? When he went for a type inside the symbol table, he got to know that variable is there but type not there. Variable is there but type not there. Can you say two functionalities of semantic analyzer? What is that one? Type checking and undeclared variables also you will identify. I'm thinking you are little bit okay, right? I'm thinking you are little bit okay. Now listen, interesting answer. See this one, see everyone. Who stored inside symbol table? Listen everyone now. Who stored inside symbol table? Mostly. All the people I am okay. But majorly which person? Semantic analyzer. Now listen everyone. Listen. Whenever semantic analyzer, careful listen. Whenever semantic analyzer will see the declaration, right, he will store all the people inside symbol table. Please be careful. Semantic analyzer want types. Whenever declaration came, in the declaration only data type is available. Semantic analyzer will store this information inside symbol table. Now again I am saying to you, can you help me now? Who need types mostly? Semantic analyzer. Next one, what the semantic analyzer will do? Semantic analyzer will store types inside symbol table. At what time he will store? Whenever declarative statement came. Declaration only contain data types and all. So somehow he got to know it is the declaration, right? So I think C compiler knows very well which is the declaration and all. Whenever he got to know it is the declaration, okay, declaration contain data types. He will take all of them. He will store inside symbol table. But one thing I am saying to you, if all is there, go to all. If you want to select, go to semantic. Right? Remember this. Right? Remember this. Next one. See the interesting answer. Listen. Whenever see this one. Whenever compilation is going on, declarative statement is came. Semantic analyzer will come into the picture. He will take all the things and with the data type and he will store inside symbol table. Please be careful because he want types. That is the reason he will store. That is okay. Now see the interesting line. Listen everyone, interesting line. One interesting line is coming. If you don't listen, you don't catch it. See this line. Suppose see this one. If at all is there, if at all declaration is there, semantic analyzer will come declaration time. He will take all the people, he will store inside symbol table. But one thing I want to ask you. Listen, At this place, what the symbol table contain? At this place. Until now it is not there. At this place, what the symbol table contain? All empty. Careful listen. Because until now declaration is not done. At that place symbol table is empty. Please be careful. After listen everyone, at this place symbol table is empty. After this line means here what the symbol table contain? Here empty. That is okay. Here what the answer? Because of this line is over. What the answer? They all will store inside symbol table. Declaration is over. Semantic analyzer stored everyone inside symbol table. What the answer? X float. Y float, he stored everything. Z float like this. At this place symbol table empty. After this line symbol table is like that. It is done by the semantic analyzer because he want types. Declaration time semantic analyzer will come, will store everything inside the symbol table. Please be careful. At this place gap. At this place all are stored inside the symbol table. Now see the interesting line. Now can you help me now? At this place symbol table is gap or not? Yes, gap. Careful, it is an interesting one. At this place symbol table is gap. Fine. Next one, see this one. If this line is there, semantic analyzer will come, he will take all the variable and types he will store. Suppose assume, interesting answer. Suppose assume. Right? This is not there. In the program is not there. Assume that. Here empty because of this line is not there. Symbol table now also empty. Whenever this line is there, right, this time symbol table empty. After this line symbol table is full. Like that is okay. Assume that this line not at all there. If this line not at all there, what is the symbol table as of now? Assume that symbol, right, this line is not there. What is the symbol table as of now? Gap only. Symbol table as of now gap because no declaration. If declaration not there, from where I will store? Right, it is a gap only because of this line is not there. Symbol table is empty only now. Now see the answer. Assume that this is the only statement. This line is not there. This is the only statement. Now see lexical analyzer started. Interesting answer. Lexical analyzer is started. Lexical analyzer is by doing calculations and all he got to know is identifier. Declaration not there. Please be careful because of that reason symbol table is empty. That is also okay. Now see the answer. What will happen? This line is came to lexical analyzer. Lexical analyzer done some calculation. He got to know it is identifier. If it is identifier, it should be in symbol table. He will go symbol table and he will check because he have to give some token number. If it is the identifier, he should be in symbol table. He verify. X is the identifier. Lexical analyzer got to know that, right? So if it is identifier, he should be in the symbol table. He came and he will verify. He got to know that X is not there. Right? Lexical analyzer got to know X is not there. Now what he will do is, see this one. What he will do is, right? He got to know X is not there. He want to say X is not there also. Means undeclared variable. Lexical analyzer want to say X is not there, so X is an undeclared variable. He want to say, but he will control himself. Why? Lexical analyzer got to know that he want token number. That is the reason he went inside. Inside X is not there. He got to know X is undeclared. So he want to inform to error handler, X is not there, X is a undeclared variable. He want to say, but he control himself. What the reason is? Lexical another goal is only tokenization. His goal is only token creation. Tokens he will create, that's it. Even though many problem, because of the first phase of the compiler, he is able to see many things, but still you don't deviate his work. His work is only tokens, right? So he got to know X is identifier. He went inside symbol table. Inside symbol table, X is not there. He got to know it is an undeclared variable. He want to say, but he controlled because it is not his work. His work is only tokens. But one thing, his work is only tokens, it's okay. But he want token number for X. X is not there. What he will do is, listen, what he will do is, he went for X. X is not there in the symbol table. But he want token number. So what is the answer? He will store X in the symbol table, but he will keep this as gap. He got to know that it is undeclared. You want to inform to error handler it is undeclared variable, but he controlled because it is not his work. You also in your life, what is your goal? Please concentrate on that. Don't deviate every time. Because lexical analyzer first phase of the compiler, he got to know so many mistakes, but he don't do all. His goal is only tokens, because for the undeclared variable and all, one more person is there. He will do his work. Everyone do his work. Can you say lexical analyzer goal only tokens, syntax analyzer goal only syntax errors, semantic error goal type checking and undeclared variable. Can you help now? Whenever he is trying for whenever he is trying X inside the symbol table, in the inside symbol table he is not there. He got to the undeclared variable, but he don't inform to anyone. He will simply store inside symbol table variable name is X, variable type not there. He will keep gap. What is the reason? Some people are asking, sir, why he is storing? He want token number. I think symbol table first row is there. He will give token number as ID1. Again, he will go for Y. Y also not there. So he got to know undeclared. But he don't inform to anyone because it is not his work. If he inform also, error handler will shout on him saying that it is not your work, you do your work properly. So what is the answer? But he want token number. He will store Y inside symbol table. He will give token number as ID2. He will give token number as ID3. He will give token number as ID3. Right? I hope everything is fine, right? So after completion of all, listen, after completion of all, that story will comes to here. While creating the syntax tree, you don't need types. Using this grammar, the token string, whatever is there, right? Can he draw the tree or not? He will verify. See, one syntax analyzer don't need types and all. That is the reason he didn't bother, right? So syntax tree is came. Now that syntax tree will go to semantic analyzer. Whenever semantic analyzer is checking the type, he want type, he will go there. Using token number, he will go. But type is not there. He will identify undeclared variable. Please be careful. Type checking. If any type mismatch error is there, is the reason for that. And one more. What is the one more error? One more error is going to be undeclared variable. Undeclared variable. Undeclared variable. Please be careful. And one more. See this one. One more thing. And one more. Who is storing? Listen everyone now. Who is storing data type inside symbol table? Who is storing data type inside symbol table? Who is that? Semantic analyzer only needed that. He only will store. He only will store. Suppose is him. Listen. Suppose is him. See this one. Declaration came. Semantic analyzer will come. He will take this one. He will store. That's okay. Now see the interesting line. See this one. Suppose 2 times I declare int x. Listen now. Int x. Right? Int x. Next one. See this one. Int x. That's okay. Float x. 2 times I declared. Same variable 2 times I declared. What is the answer? First time declaration came. Semantic analyzer will come. He will store. Second time also came. Second time also came. Semantic analyzer will come. I think because of this x, while storing, he will check. Already there again came multiple declaration. Multiple declarations. One thing is true. One thing is true. Data type related thing. Declaration only contain data types. Declaration only contain data. Listen everyone now. Declaration only contain data types. Everyone know. Whenever declaration will come, semantic analyzer will come, he will try to store. He will try to store. While storing, he got to know. X is declared 2 times. Multiple declaration also. And one more. If at all no declaration, he don't store. If no declaration is there, no data types, then semantic analyzer don't store. Then who will store? Lexical analyzer will store because he want token number. He want token number, he will go, but nowhere there. So he will store X in the first row, token number he will take ID1. Can you help me? I am saying one small line I am saying to you. Who can store inside symbol table? Don't confuse. Who can store? All. Best answer is all. If all is there, select all. If all not there, what is the answer? Semantic analyzer. When he will store? Declaration came, he will store. Every declaration, semantic analyzer will take and he will store. Semantic analyzer will take, will store. So, I think all not there, semantic you can go. Suppose that semantic also not there. Who can store? Lexical also storing. Lexical also storing. What is the reason? He want token number. Because of lack of declaration, semantic analyzer don't store. Lexical analyzer want token number. He got to know in the symbol table, no one there. I think he want token number. So he will store somewhere without type he will store. Variable X he will store, data type not there. So he will give token number ID1. So finally all will store, that is the one answer. If not there, right? Next answer, if you want to select semantic, declaration there he will store. Suppose it is also not there, lexical, what is the reason? I think no declaration he will store. Declaration there, semantic will store. Declaration not there, right? Lexical will store, right? Like that. All also okay, right? Not there, semantic also okay, not there, lexical also okay. If these two also not there, you select anyone. But one thing, just to follow priorities. All fine. If not semantic, if not lexical, if not anyone, you can select. Right? Fine. Now can you help? And I think it's the correct time to ask you. Please listen. Who will take care about all syntax error? Syntax analyzer. Drawing tree means what? Syntax correct or not, he will check. Can you help me now? What is the semantic analyzer goal? Type checking, undeclared variable, and one more. Multiple declarations also. Multiple declarations. Some people are asking how multiple declaration. Whenever a declaration came, he will go and he will store. Same person came in the declaration twice, right? He got to know multiple declaration. Multiple declaration. Right? Fine. It is the correct time to ask you. Semantic analyzer input, syntax tree, output, modified parse tree. What are the responsibilities of semantic analyzer? Type checking, undeclared variable finding, multiple declaration. All meaningful things he will take care. All physical things, physical problem. What is that one? Semicolon missing. Next one is going to be bracket missing. All syntax related things. Syntax, right? According to the C language, whatever syntax errors you will be able to see because of him. Physical errors he will take care. Logical errors he will take care. What is the logical error? Both will be same type, then only add. Both are same type, then only perform any operation. Next one. If variable is not declared, don't use. Don't declare the same variable multiple times. These are the right logical things. Next one, physical things are going to be, right? I think after every line, semicolon required. Next one, before open bracket, closed bracket. Open should come first, afterwards closed. You know all the syntax errors. In the program, when you compile, if you see any syntax error, is the reason for that. If you see semantic error, is the reason. Semantic means these three. Next one, tokenization time if any problem came. That is going to be lexical error. Another name, token error. If you see, listen, after compilation is over, if you see on the screen, token error is the reason. Lexical error is the reason. Next one, syntax error is the reason. Semantic error, this is the reason. And one more thing I want to ask you. Until here successfully over means your program don't have syntax errors also, semantic errors also. Until these three phases successfully completed means your program don't have syntax error also, semantic error also. Then what is the answer? From now onwards, concentrate on conversion. Can I say what is the purpose of compilation? Purpose of compilation is going to be converting high level to low level. Now concentrate on conversion. Until now I am not done conversion. Until now I am doing checking only. Analyzing means checking. Until now I am analyzing only. What is the meaning of analyzing? Your program is syntactically, semantically correct or not. Actual purpose of compilation, conversion from high level to low level. I am not done any conversion until now. The reason is I have to verify program correct or not. If program syntactically, semantically correct, then I will convert. Assume that these three phases without any error completed. What do you mean? Program syntactically, semantically correct. Now you have to do conversion. Can you help me now? Intermediate code generation, input, syntax tree. What is the output? I will see now. What is the output? And one more thing, listen, one more thing. When you are, listen, from now onward, token numbers and nothing required because verification completed. Analyzer means what? Lexical analyzer, syntax analyzer, semantic analyzer. Analyzer means checking. Checking is going on. I think checking successfully over. Now conversion. Checking successfully over. Now conversion is going on. Conversion. Because of conversion is going on, token numbers not required. Take actual things. Take actual. Can you see this one? See this diagram. See this diagram. Can you see in this diagram if you observe? Assignment operator plus operator star operator. Assignment plus star. Can you help me now? Which is having highest priority according to C language? You know, without getting answer, you cannot assign. He may be there in the first place, but he will be done last. Why? Without doing this, how can you assign? You know very well we done also. Can you help me now? Assignment having least priority, plus and star is highest. What do you mean? Star will be done first. Next plus, next assignment. Can you say what is the star? What is the star? You only say actual thing. ID3 is a token number. What is the actual? Symbol table third row. Symbol table third row, who is there? Symbol table third row, who is there? Z is there. All type checking, everything is done, right? That is the reason from now onward token numbers are not required. Take actual. What is the answer? So first star will be done. What is the star? ID3 means what? Z. Now let me check this one. What is the answer? Z into 60.0 will be done. That will be done in one temporary variable T1. Next, this is T1. It is done. It is the T1. Next, after star, next plus. What is the answer? Plus is going to be ID2 plus T1 because this is already done at the T1. So what is the answer? ID2 plus T1. So what is the answer now? T2 is equal to ID2 means what? Y. Y plus T1. This is the next operation. First star will be done. Next plus will be done. That is T2. What is the last one? ID is equal to E. This is T2. This is T2. Next one. ID is equal to T2. What is the ID? ID1. ID1 means what the token number is ID1. What is the actual X? X is equal to T2. This is going to be intermediate code generation. Nothing they see, every intermediate operation. According to priorities you do. It is the highest priority, it is the next priority, it is the next priority. So, intermediate code generation is nothing but dividing that expression. One thing is to see this one. One thing is to see carefully. See carefully. This expression is equal to this tree. Both are same. This expression is equal to this tree. Both are same. It is a linear representation. This is the linear representation. It is a tree representation. Both are same. That expression and this one, it's the tree format, right? So please be careful. Please be careful. The expression, can you say what is the expression of this tree? ID1 is equal to ID2 plus ID3 star 60. This expression, right? We done into small parts. First small operation star. Next small operation plus. Next small operation assignment. This is called intermediate code generation. First to do star, next to do plus, next to do X is equal to T2 assignment operation. Some people are asking, sir, why are you converting? Verification is over. Analyzing over means verification over. Verification successful. Then come to the conversion. Verification successful, I came here. Next, see the next one now. Next one, see this one. This is the intermediate code generation. Next one is code optimization. Let me write now. Code optimization. Code optimization. Code optimization. Can you help me one small line now? What is the code optimization answer? Let's check. Code optimization. Can you help me one small? If you want, you can check. See how I am optimizing. See this one. T1 is equal to Z into 60.0. T1 is equal to Z into 60.0. That is the T1. Z into 60.0. Can you help me one small line? Listen everyone now. What is the next one? T2 is equal to Y plus T1. See this one. Y plus T1 is equal to, listen, Y plus T1 is equal to T2. T2 will goes to X. What is the meaning? You are storing this answer in T2. T2 finally going to X. Instead of storing T2, T2 will go to X. Directly store X only. Code optimization. T1 is equal to Z into 60.0. So X is equal to previously T2, it will store in T2, T2 will go to X. So directly I stored X. I think some optimization done. Some optimization done. Please check. If possible, suppose some people are asking, sir, not possible optimization. Keep as it is. If possible, optimize. If not possible, keep as it is. What is there in that? Right, next one, see the next one now, this one, listen everyone now, this one, write in the form of, right, assembly language statement. Same thing, assembly language statements you can use, that is called target code generation. Target code, write the same thing in target code generation. Some people are asking, sir, what is the meaning of target code? Nothing there, very simple. See this one, star means what? Star means mul. Next one, plus means what? Yeah, something like that. Like that you can convert. It is not that much important simply by seeing this one, right? Every one contains this one, every one assignment it's okay. Every line contain one new arithmetic operator. Star, multiplication, plus, add, like that. Just convert, right? Maybe mul R1, R2, something like that. Right? Next one, mul R3, R4, something like that. It is really not required, simply convert all these statements by seeing this one. Okay, star, multiplication, plus, add, like that you can convert. This is really not required. It is not there in the syllabus also. Syllabus is until here, code optimization. Until last year, if you see, last year is until intermediate code. Now this year code optimization also until here. Target code not there because simply mapping only. Okay, for this one, okay, matching statement is mul in the assembly language. For this one, matching statement is going to be add, like this. See, these three steps became very easy because this is a conversion. This is the conversion, this is analyzing. This is analyzing. When you compile a program, you will see so many semantic error, means these. Type checking, undeclared variable, multiple. Next one, when you compile a program, so many syntax errors you will get. Syntax error means what? For the, right, the expression what you written, syntax tree not possible. The expression what you written, see in your program, so many expressions you will write. So many expressions, right? Many expressions may not be possible. Then many syntax errors. Only one expression not possible. One syntax errors. For every line of your program, one tree will be constructed. Tree possible successfully for every line. No syntax error. One line also tree not possible. At least one syntax error you will get. Next one, while doing token, you will divide the given program into token. There itself error came, token error. Right? So this is the, can you help me note the topic name? See the topic name, everyone know this. See the topic name. Introduction to compiler. This is the topic name. Topic name is Introduction to Compiler. In that, first initial few minutes I said, language processing how. But major one is compiler, go there. Compiler means software which internally contains 6 functions. What every function will do, I explained with the help of one example. Right, mostly I think most of the places you got 1 or 2 things you may not get, but just remember only one thing. Every phase, what are the input, what is the output. How tokenization is done, see, is having some rules. Until unless you don't know the rules, how you know how the tokenization. So I will say within few minutes that also. Right, lexical analyzer, how it will do tokenization, I will explain, don't worry. Just to see only one thing, what is the input, what is the output. Lexical input, high level language, right, statement, output, right. Input is going to be high level language statement, output is going to be token statement, or high level language string, token string. That is input to syntax analyzer which will create syntax tree. That is the input to semantic analyzer which will create modified syntax tree. But while doing the modification, he is doing type checking also, undeclared variable or not, multiple declaration, like that. Suppose analyzing successfully completed. Then go for conversion. Conversion, nothing there. Right, intermediate code generation. For every arithmetic operator, right, one temporary variable. The name itself saying intermediate code. What is the meaning? Every intermediate operation, one intermediate variable will come. See, first intermediate operation, right, one temporary variable, one intermediate variable, one more intermediate operation, one more intermediate variable. It is not intermediate operation, it is the final operation. There is no intermediate variable. Next one, after writing this one, right, that optimization, if possible, do. If not possible, same thing there. If not possible, same thing there. And one more thing I want to say to you, listen, in some compilers what happened is, while writing intermediate code itself, they will write carefully, then no requirement of code optimization. In some compiler, they will write the intermediate code first, on that they will do optimization, then they will get That is, some compilers will do. In some compiler, no code optimization. Directly in the intermediate code itself, they will do code optimization. While writing intermediate code itself, if you do properly, this is not required. So this phase is optional in some compiler. In some compiler, code optimization is there. Some compiler, code optimization not there. Right? Please be careful. And one more thing I want to ask you. See, so after compilation is over, what are the final output? What are the final output? Machine language statements will come. See, assembly language statements. After compilation is over, if you see the final output, you will see machine instructions. You will see the machine instructions. Please be careful. Now, one more thing I want to ask you. Some people are asking, right, after compilation is over, final line is belongs to machine instructions, everyone know. Suppose assume that in that particular computer, machine means what? Processor. Suppose assume that in that particular computer, right, i5 processor is there, right? Output is going to be i5 statements. Meaning is same, right? In that computer, i5 processor is there. These are the instructions of i5 processor. Suppose in that computer, i5 is not there. i9 is there. Sorry, i7 is there. These are the i7 instructions. Please be careful. Suppose in that computer, P4 processor is there. These are the instructions of P4. What is the meaning? I think, right? I think everyone know. One processor to another processor, instruction set is little bit slightly changed. One processor to another processor, instruction set, right, slightly will change. See this one, same statement may not be available in some other processor. So equivalent to one, something else will be there. Processor to processor, instruction set slightly will change. Can you help me one small line? In that computer, P4 processor is there. These are the instructions of P4. In that computer, i7 processor is there. These are the instructions of i7. What is the meaning? I think the final code, whichever is coming, it is the machine dependent code. Depending upon processor, that kind of code will come. Machine dependent code. Please be careful. Some people are asking, output of compiler finally, target code, which is nothing but machine dependent code. What is the meaning? In that computer, which machine is there, right? That kind of instruction set will come. Right? P4 processor is there, P4 instruction set will come. i7 processor is there, i7 processor instruction set will come. So final output, machine dependent code. Please be careful. This output is machine dependent code. Suppose some people are asking me, sir, what about here? Can you help me one small line now? You only say, is it machine dependent code or machine independent code? Say, there is no machine instructions. There is no machine instruction. So this is the machine independent code. It is the independent. See, nowhere null is there, nowhere add is there. This is going to be machine independent code. This is going to be machine dependent code. Please be careful. I hope you are okay. Can you say which phase of the compilation is optional? Code optimization. And one more thing. After target code is over, whatever code you are getting, is it machine dependent or independent? Dependent. P4 processor, it is the P4 code. i5 processor, it is the i5 code. Right? Suppose here if you see, is the machine independent code or dependent code? Independent. P4 processor, then also same code. i5 processor, then also same code. What is the reason? This is not a machine code. It is the intermediate code. Please be careful. It is the intermediate code. Right? I'm thinking you are okay. Listen, Please listen this. You are almost fine. And one last question I want to ask you. Many times I said to you, last question I want to ask you. When lexical manager will store inside symbol table, I have here one variable. Right, lexical manager will store that symbol inside the symbol table when declaration there, semantic will store. Declaration not there, lexical will store, because lexical will go inside to give the token number, but nowhere there. He will store and then he will give token number. If there, he will give directly token number. If not there, he will store and he will give token number. But that time, data type he don't store. Semantic analyzer, declaration came, semantic analyzer will store. But one thing, all people have right of storing inside symbol table. That's it. Right? You are really comfortable. Let's see one small thing which is pending. See this one? See everyone now. Lexical analyzer, syntax analyzer, semantic analyzer, Next one is going to be intermediate code generation, code optimization, target code generation. Right? These are the 6 phases of compilation. So if you do, listen everyone, if suppose that I compile my program, careful listen, I compile my program, if I compile my program, all phases are running, listen, all phases are done, then what will you get? This phase also done, then you will get the machine dependent code. Suppose that when I compile, right, you only say, when I compile, all 6 phases are done, this also done, then you will get the machine dependent code. Is it right or not? Suppose that only first 4 done, see this one, until here only you done. On my program I done compilation, only these 4 phases are done, remaining not done. Can you say what the output you will get? You will get the machine independent code. Is it right or not? Not machine dependent code. Machine independent code you will get. Is it right or not? Java compilation is done until here. Java compilation is only half compilation. Because you will get in the Java language, if you see machine independent code you will get. What is the meaning? What is the advantage with the Java compilation? You know, JVM. What is the Java compilation? What is the advantage? Right? Listen everyone now. If you compile Java program in one system, the output whatever came after compilation, take that code, right? You can run that code in any system. What is the reason? It is the machine independent code. Java compilation will be done only half compilation. What is the meaning? Only until intermediate code Java compilation is done. Take that code, right? Run in any system. There is no problem because it is the machine independent code. What is the meaning? In any system they can run. But if you see the C program, if you compile, all 6 phases are done. What is the answer? You will get the machine dependent code. What is the meaning? Take that code, right? I got this code in a computer who is having processor i5. What is the meaning? This code related to i5 processor. Take that code, right? Run in some other system who is having P4 processor. It don't run. That is the meaning of machine dependent code. So C compilation is going to be, what is the answer? Machine dependent code. What is the meaning? Right? It don't support the, right, portability. C compiler don't support the portability. What is the meaning of portability? Compiling in one system, running in other system, not possible. Java compilation, right? Follow the portability. What is the meaning? Compiling in one system, running in other system. What is the reason? Anyhow, it will generate machine independent code. But C compiler will generate machine dependent code. Portability will not come. Java compilation, portability will be possible. Right? Please be careful. If from now onwards, if anyone say to you, Java compilation, portability possible, why? It will do only half compilation. What is the meaning? Only until intermediate code they will do. So you will get the machine independent code. So in any system you can run. But C compilation, if you see, full compilation you will do. Right? You will get the machine dependent code in that system only you can run. Or similar kind of system. Right? If you go for some other system which is having completely different behavior, it don't work out. You know, mostly everyone know that. Right? Now listen this. Listen everyone. Listen this line also. So total compilation actually contains 6 phases. You know very well. Now see this one. This one, from lexical to intermediate code generation. This is called as front end of the compiler. Front end of compiler. From lexical to intermediate code, this is called front end of the compiler. Right? Only target code is called as back end of compiler. Only target code is called back end of compiler. Right? First 4 is going to be front end of the compiler. If anyone asks you, you say, otherwise not required, really not required. Next one, see this one. This person, only code optimization. This person is called as, right, middle end of the compiler. Middle end of compiler. Only code optimization is middle end of compiler. Before is going to be front end of compiler. After code optimization is going to be, right? So back end of compiler. They may ask you which phases belongs to front end of compiler. First 4. which is belongs to back end of compiler target code, right, which is neither part of front end, neither part of back end code optimization, which is also called as middle end of compiler, right? I'm thinking you are little bit okay. Next one, which phase of the compiler is optional, right? Code optimization. This is the optional phase of the compiler. Optional phase of the compiler. Right, that is also fine. Now see the next one, one more thing. See this one, one more thing. Listen, one small point I am saying to you, just listen this also. Lexical, syntax, semantic, intermediate code generation, code optimization, target code generation. See everyone now. Compiler contain, right, 6 functions or 6 phases. It's okay. Now see the next line. See the next line now. These 6 phases combinedly, if you see how many lines of code, because the compiler is a complex program, how many lines of code? 10 lakh lines of program, right? 10 lakh lines of code is there. This total thing, if you see 10 lakh lines of code, please be careful. Compiler is a complex program which internally contains 6 functions, combinedly contain 10 lakh lines of code, right? Remember this. Now listen, next line. See this one. I have a program. On that program, I said compile. I have a program. On that program, I said compile. When I say on that program compile means, right, on my program, on whom I said compile, right, definitely these six functions means 10 lakh lines of code is running. On my program, I said compile means this total compiler code is running. What is the meaning? 10 lakh lines of code is running on my program. This 10 lakh lines of code is running on my program means these 10 lakh lines of code should be there in main memory. Otherwise, how it can run? My program is compiling means on my program, these 10 lakh lines of code is running. These 10 lakh lines of code is running means, right, these 10 lakh lines of code should be there in the main memory. Suppose assume that main memory can accommodate, right, only 5 lakh lines of code. But this code is 10 lakh lines of code. 10 lakh lines of code is running means these 10 lakh lines of code should be there in the main memory. But main memory can support only 5 lakh lines. But the 10 lakh lines, then what is the answer? Total compilation cannot be done at a time. Then what I will do? Half compilation I will do. Right, after half compilation is over, whatever output is came on that remaining compilation. What is the meaning? If you do compilation in multiple passes, that is called multi-pass compiler. If you do total compilation at a time, suppose total 10 lakh lines of code is running on my program, means 10 lakh lines of code should be there in the main memory. Main memory can accommodate that much code. Then there is no problem. That is called single pass compiler. Listen everyone now. Total compilation at a time done. Single pass compiler. Total compilation, multiple passes you done. Multi-pass compiler. When the people will go for multi-pass compiler, memory, right, main memory is very small. Then go for multi-pass compiler. Main memory more, then go for the single pass compiler. But one thing is true, if the memory is small, right, multi-pass compiler, what is the meaning? Many times going, many times coming, means time is more. If single pass compiler, one time going, one time coming, context switching, more context switchings are there, more time, less context switchings are there, less time, right? Last time I want to ask you, compilation can be done, right? Multiple passes also, in one pass also. If you do one pass, single pass compiler. If you do multiple passes, multi-pass compiler. When multi-pass compiler, people will go, main memory is very small, right? So memory less, then multi-pass is better, but time will be more. Next one, memory more, single pass is better, right? Then memory more required, single pass is better, then time less will come, right? Let me do that small line also. Let me write. Total compilation once. Total compilation at a time. Then single pass. Then single pass compiler. Total compilation at a time, single pass. Otherwise, multi-pass. Next one, single pass. Single pass. Can you help me now? What is the drawback? Right? Space is more or less? Space less. Sorry, single pass. Single pass, what is the answer? Space more required. Space more required, but time is less. Time is less. Next one, what about otherwise? It's the multi-pass. Multi-pass means less space is okay. Right? But more time required. Right? Fine. Single pass compiler. What is the advantage? Less time. Less time. Drawback, more space. This is the advantage. Less time. This is the drawback. Next one, multi-pass compiler. Advantage, less space. Drawback, right, more time. It is the drawback. So one big story I said to you, right? If anyone having small confusion also, please check again and again. Many times I repeated also. Okay, some people are asking one small line. In symbol table, why are you storing only identifier? Why not others? Others are already there inside compiler. That is the meaning of installing Turbo C compiler. You already installed means you have all. Only user defined things not there. Those will be there in the symbol table. Who will store inside symbol table? All. Mostly all. Suppose if you want to say one, semantic. If you want to say two, semantic and lexical. Right, like that. Next one, declaration time. Declaration time only data type is there. Then semantic analyzer will come and store. If declaration not there, lexical will store. Next one, syntax analyzer purpose. Syntax errors finding. Tokenization, listen, lexical analyzer purpose, tokenization. Semantic, all semantic error. What are the semantic error? Type checking, undeclared variable, multiple declarations. Next one, first three phases called analyzing the program. Analyzers. Afterwards, conversion. Conversion is very simple. In some compiler, intermediate code writing itself, they will write carefully. Code optimization is not required that time. If you do compilation until intermediate code, then you will get the machine independent code. Advantage, on any system you can run. If you do until last place, you will get the machine dependent code. You don't get the portability. Why you don't get the portability? The platform dependent. Portability not possible. Next one. Whenever compilation is going on means, right, on your program, 10 lakh lines of code is running. Means 10 lakh lines of code should go to main memory. But main memory having very less space. So total compilation you cannot do at a time. Do multiple passes, multi-pass compiler. Advantage is less space you can manage, but more time because more context switchings. Total compilation at a time, single pass. Advantage, right? Advantage less time. Drawback is, right, space more required. At a time means what? More space required. Next one, listen, lexical to intermediate code is called front end. Only last one is back end, right? Code optimization is middle end. Fine. This is the introduction of compiler. Right? If any small doubts are there, in the next chapter you can see, because introduction is always like that. Introduction itself, how will you get all? If you get all in the introduction itself, why I will cover the remaining chapters? 6 chapters are there, or 5 chapters are there remaining. What I will do there? So, little bit if you get, it's okay. I'm thinking you are absolutely fine. Right? So, we'll see next chapter in the next class. That is the lexical analyzer. We'll see that.